Hey grade 12s and welcome to this video. In this video, we're going to be working on the NSC Maths Paper 2 for June 2023. Okay, so normally we just have all the usual instructions and let's just quickly already start on question 1. Now, I would like to mention I'm going to be using this calculator, but I also have my own calculator out. So I just have to check certain steps that you're going to have to take on the calculator, and then I'll let you know. But I'm going to use this one. Okay, so question 1 says 1.1. The owner of a small company wishes to establish whether advertising in a regional newspaper is effective. The table below shows the amount spent on advertising and the corresponding sales figures for the last 9 years. Okay, so there's some small company, person keeps advertising on a newspaper, and this is the amount they keep spending throughout all the years. So this is the first year, second, all the way to 9 years. And then this is the sales that they are making. So they basically just want to see, is the money that they're spending on the advertising, does advertising affect the sales? Okay, so the first question we have is determine the equation of the least square regression line of the data. Okay, so this is just steps that you're going to have to take. Remember, the equation of the least square regression line is y is equal to a plus bx. Okay, so we're going to have to find the value of this a and the b, and then our equation will be complete. So let's go ahead and find a and b. So we're going to put in this information. Now, the nice thing is that they're already telling you that these are the x values and this is the y value. The reason I'm saying that is because they don't necessarily have to actually tell you that. They can actually just say the information, and then you're going to have to think about which one would be your independent or your dependent variables. Okay, but in this case, they already gave you that. So with this part, just be very careful as you're putting in the information. So as we're going to put this in, this is what we're going to have first. You're going to, first of all, on your calculator, so on your own physical calculator, you're going to first press mode. And then when you press mode, you're going to see 3 options, I think, pop up. So I'm not really using a Casio calculator, but it is a scientific calculator. Then you're going to go ahead and press. Okay, so never mind. I found the Casio calculator. So I'm going to be using that. Okay, so I am using the old one. I do think the way it works is still exactly the same. I think they just changed the way it looks. So first of all, we press mode, and then you're going to see 3 options pop up. One is going to be comp, then stat, and then 3 for table. So since this is information that we need to put in, it's not functions. We're going to go to stat. So statistics, so 2. And then you're going to have a whole lot of options, and you see that number 1 says variance, VAR, and then number 2 says A plus BX. So that is about regression. You're going to choose number 2. Okay, so as you can see with mine, I am still going ahead. So mode, then I choose stat, and then of course I'm going to go to this A plus BX, that, because it's the paired, the bivariate data. So yes, you're also going to have something like this. You may not have a frequency table like this side. So let's put in the x values first. So the first x value you have is this 21300. Just carefully put everything in. I'm going to put everything in now, and then just make sure that everything is in properly. Okay, so these are all the x values that I've put down. You will see that on the side on your calculator, you're going to have numbers. So just make sure that you end at 9 because they are 9 years. Okay, then move on to the y column, and we're going to put in the y values, the sales. Okay, so now that everything has been put in, the y and the x values, on your calculator, you're going to press the button AC, and then you're going to press shift and 1. Okay. And then you'll see that you're going to have like 6 options, but you just have to go for option number 5, which says REG for regression. And then you'll see that you have 5 options, and number 1 and 2 give you the value of A and B. So let's go for number 1 first. So you're going to press 1, and let's see what that A is equal to. Okay, so my A value, I get 1730 points, and then rounding off to 2 decimals because this is money that we're talking about, so that will be 22. Okay, so that's the value of A. Now, in order to find B, you can just press AC Shift 1. Even if you just press Shift 1, it will work, but I just like to press AC. So AC Shift 1. And then again, you're going to go back to that whole thing with the 6 options. Then you just have to choose option 5 for regression. And then after choosing option 5, you're going to go for number 2 this time, because we want to find out what B is. So if you go for number 2, you see that B is actually just equal to, and we get 13.96. Okay. So now as an equation, this is just y is equal to the A value, which is 1730.22. And then plus, this is positive, so we can say plus 13.96 and x. And there we go. So that's the equation of our least squares regression line. Okay, so moving on to the next question. The next question says, predict the sales for a year in which the company will spend 28,500 Rand on advertising. Okay, so look for what they are asking you for. They want you to predict the sales. Okay, so let's see. What does the sales refer to, X or Y values? The sales refers to Y values. So they want you to find the Y value, okay, for which the company will spend this amount on advertising. Okay, so they're spending this on advertising, and advertising is referring to the X values, the amount spent on advertising. So that is X. So they're giving you an X value. They want you to find a Y value. To predict this, you're going to use the equation of the least square regression line, because that's all we have right now. Okay, we never drew a scatter plot or anything. So we're looking for Y. So we're saying Y is equal to, and we have 1730.22 plus 13.96. And then in place of X, we're going to put this amount. So that is the 28,500. And let's go ahead and see what we get. Okay, so the nice thing about these calculations is on your calculator, even if you press AC, it's not going to remove the information. It's still recorded, and you can still do normal calculations here. So I'm going to do that calculation. 17,030.22 and then plus 13.96. Open bracket, and we're saying 28,500, and we're going to get an amount. So let's take that. So that is our answer there. So the amount, or the predicted sales, is going to be 399,590.22 cents. Okay, so that is 1.1.2 done. Moving on to the next question. They want us to write down the correlation coefficient of the data. So the correlation coefficient is going to be found in the recorded data that you have. On your calculator, just press AC, then Shift, and then 1. And then when you press that on your calculator, mine is a bit different, you're going to get those 6 options again. Go for option 5 for regression. And then again, you're going to get the 5 options. And this time you're going to choose option 3, which is R. Okay, so that's your correlation coefficient. So let's see what that is. So as we can see, R is equal to, if we round off to 2 decimals like we're supposed to, it is 0.98. Okay, so sorry, I put it in the wrong place. 0.98. Okay, and then moving on to 1.1.4, which is the last question regarding this bivariate data. So we have described the association between the amount spent on advertising in the regional newspaper and sales of the company. So they want us to describe the association. When we speak about that, this is what you're going to have to remember. You're going to have to remember how the correlation coefficient works and the association that is attached to it. Okay, so let me just run through the correlation coefficients and what they mean. I'm not going to go too deep into it. So looking at these numbers, they just represent different correlation coefficients. If your correlation coefficient is 0, there is absolutely no correlation or association, meaning that your data has nothing to do with each other. The X values are not affecting the Y values. In other words, the amounts that they keep spending on advertising is not affecting the sales. That's what a correlation coefficient of 0 would mean. This one would be weak. Okay. 0.5 is exactly halfway. So this would be moderate. Okay, so just in the middle, moderate. And then this 0.9 would be regarded as strong. And if your correlation coefficient was 1, that would be perfect. And this works the same with the negative numbers as well. Okay, so -1 will also be perfect. So when we speak about the correlation coefficient, you first really speak about their strength, and then you speak about whether it is positive or negative. And then you say it's an association. So here we have 0.98, which would fall within this. So around 0.9, that is a strong association. So this is how we're going to really just say this. It is a strong, and remember the number is not negative, it's positive. So it's a strong positive association. Even if you said strong positive relationship or strong positive correlation, it's still going to be fine, because it's really just speaking about the relationship between the two values. Okay, so that is exactly the X and Y values. So it means that really in this information, the amount that they keep spending on advertising is actually affecting the sales. Okay, so you wouldn't really need to put any of this down. I just put that there just so that we can write that down. Okay, so you would just really need to say this part written in black, that's all. Okay, so that's your answer there. Then the next question, we move on to 1.2, and we have been given a new set of data. So we won't need this anymore. Okay, so 1.2 says, the profit that the small company made over the same 9 years is given in the table below. So you see in the previous one, they gave you the sales, but here we're actually talking about the profits. Okay, I'm going to remove this information. We're not going to need this. Okay, so you can go back to comp. We will go to stat, but it's going to be a different way. So first of all, we've been given these 9 numbers because it's for 9 years. And they want us to calculate the mean profit made over the 9 years. Okay, so this is worth 2 marks. We can use the calculator to calculate the mean without actually adding it up together. So to find the mean, we're going to say this. On your calculator, you're going to press mode. Then again, remember we are speaking about statistics, so stat. Then this time, you're not going to choose option 2 anymore for .a plus bx because we're not using bivariate. This is one set of data. So we're only using one value. It's not bivariate. It doesn't have 2 sets of data. So we're going to go for option 1 for variance. So you're going to see you've been given a column with numbers like 1, 2, 3 going down, and then it's written X on top. So we're going to put in these values in here. Nicely put them in. Try to make sure you don't make mistakes with it. And then let's see what we have. Okay, then after you've put all the information in, you're going to press AC, Shift, and then 1. Then on your calculator, you're going to have 5 options: type, data, sum, variance, min, max. Okay, so you're going to go for variance, number 4. Okay, I apologize. I keep using the word variance. It's not variance, it's variable. So it's speaking about the amount of variables. So it says 1 variable. So the ones with just a single variable, not like the one we did here with 2 variables. Okay, so once you press that, you're going to see that you have 4 options. Number 1 says N, which is really just the frequency. Number 2 has this symbol, which is for mean. Okay, so just press option 2 is equal to, and let's see what we get. Okay, so the mean, we get 172,466.11 cents, and this is money. So this is the mean, or basically the average of the profits that they have made in the 9 years. Okay, then the next question after the mean, we have to write down the standard deviation of the data. Okay, so to find the standard deviation, you can go ahead and press AC, Shift 1 again. Then again, you're going to see your 5 options. You're going to go for option 4, which says variable, so option 4. And then we want the standard deviation. So the standard deviation, the symbol of it looks like this. So yours may say this and X, but even if it's just that, it is still the standard deviation. So the standard deviation, that's option 3. And you can go ahead and say is equal to, and let's see what we get. So the standard deviation is 56,950 point, round off to 2 decimal places, 0.9 cents. Okay, so that's our standard deviation. And remember, the standard deviation really just measures, it is a measure of how spread out your data is. So the mean would really just measure the average. Like if you took a class test, they can test the average of the marks that you guys received. Then the standard deviation will tell you more about how spread out the data is, meaning how close it is to the mean. Okay, so that is 1.1.2, and then moving on to 1.2.2. Then moving on to 1.2.3, we have determined the number of years in which the company made a profit that was greater than one standard deviation above the mean. Okay, so we have to find out the amount of years where the company made a profit that was greater than one standard deviation above the mean. A way that you can look at this to understand this is we're looking at the mean, right? And we need to move one standard deviation above the mean. So if we're moving above the mean, we're going to add. It's kind of like we're moving to the right. And we're going to add by one standard deviation so that we can be one standard deviation above the mean. So if they said 2 standard deviations above the mean, it's like looking at, you have the mean here and you're going to move 2 standard deviations. Okay, so like 2 times the standard deviation. If it was below the mean, if they said 1 standard deviation below the mean, you'll be looking at the mean and you'll be moving this way instead to the left, meaning you'll be subtracting and you need to just go 1 standard deviation below the mean. So it'll be the mean minus the standard deviation. Okay, so that's really how to work out these ones. So first of all, we need to find out what that mean plus the standard deviation is, because this will be 1 standard deviation above the mean. Okay, so let's find out what mean plus the standard deviation is. So the mean was this number, which I'm just going to put down. And then we have to say plus the standard deviation, which is this amount, so 56,950.09. Okay, add this on your calculator and let's see what we get. You don't have to worry about the data. We don't need it anymore. As you can see, this is the last question in statistics here. So I'm going to just put the calculator back on the normal setting. You just press mode and number 1 for comp. And we get 229,416.20. That's how much we get. Okay, so that solves that mean 1 standard deviation above the mean part. But now if we look closely to what they're actually saying, they're saying we need to determine the number of years in which the company made a profit that was greater, okay, than 1 standard deviation above the mean. So if this is 1 standard deviation above the mean, we need to look for how many years did they have a profit that was greater than this amount. Okay, so we're going to look in the information. What was greater than this amount? Okay, so let's see how much numbers here is actually going to be greater than this number. Okay, so greater than that. You see, this one is not greater than it. This one, it's in the 100,000s, not greater, not greater. Okay, let's compare this one. As you can see, this is greater than that. So that we're going to take 1. This one is less than that. This one is definitely greater as well. This one less than. This one, it's less than. So we cannot take that, and that's less than. So as you can see, we only have 2 profits that are literally greater than 1 standard deviation above the mean. So you need to remember how to answer this. The question is determine the number of years. Okay, so how many years did they have a profit greater than 1 standard deviation above the mean? That is 2 years, because 2 profits were greater than a standard deviation above the mean. So you need to just conclude 2 years. Okay, that would be the answer. Okay, so that is it for statistics. Well, no, just this part. Yeah, we still have this. Okay, so that is it for 1.2.3. And then we move on to question 2 with group data. So now we're on question 2, and question 2 says the ages of people who attended a music concert were summarized in the table below. So here's this table, and the first question is to write down the modal class of the data. So the modal class really refers to the mode, but in this case, this data is in classes. So the mode would be the number with the highest frequency. Because remember, the number of people, okay, the frequency, that's just really how many times this information would occur. Okay, but these people are being grouped in classes, because they're not really going to now represent all the ages of each people. These people are too much, so it's in a group. So we're just going to take the thing with the highest frequency. So here, that frequency is 90. That's the highest. So the class with the highest frequency would be this. And so we're going to take that. That is where X is greater than 35, but less than or equal to 45. So people who attended this concert the most would be within this age range. Okay, the next question. How many people attended the concert? So remember how all of this is speaking about the number of people. So to find out the amount of people that they are, you would just have to add all of these numbers up and we will get that. Okay, so I'm going to add everything up and let's see what we get. Okay, so when I add all the number of people up together, we get 320. So it means that there were 320 people, okay, that attended the concert. Moving on to the next question. 2.3, they say, on the grid provided in the answer book, we need to draw a cumulative frequency graph, an ogive, to represent the above data. Okay, so I just pasted the ogive that they gave. Nicely, they've already told you that they're already doing this for you, and that's really nice. So you just really have to plot down the information. Okay, in order to plot down an ogive or cumulative frequency graph, we need a cumulative frequency column. And this is how we can create that. So that I'm going to put cumulative frequency here. And this is how we calculate this. So very easy. We're going to take 20 first and drag it to the side. So we have 20. And then we're going to say 20 plus 25, and that gives us 45. Then 45 plus 60, and that will give us 105. And then 105 plus 90, and that'll give you 195. Then 195 plus 55, that's 250. And then 250 plus 40, 290. And then 290 plus 30, which is 320. So you see, we ended off at 320, so we know it is correct. Okay, so that would be your cumulative frequency. Okay, and this is how we're going to now plot this information down. So remember, you have an x-axis and a y-axis. How we're going to put the information down? On the x-axis, okay, this is the age of people. As you can see in the data, this is the age of people. And then this will be our cumulative frequency. Don't use the frequency, use the cumulative frequency. That will be on the y-axis. So this is how we're going to put it down. The first one you're going to put down is going to be 5, whatever number starts here, okay? It's 5 in this case. The x value will be 5 and the y value will always be 0. That's where you start. So your x value is 5, your y value is 0. So as you can see, this is from 0 to 10. So we need to go halfway in between. We need to say 5 and 0. Okay, so looking at the way this thing is counting, it's counting in intervals of 5. So it's like 0, 2, 4, 6, 8, 10. Okay, so since it's 2, 4, this is 4. And then 5 will be in between that. So I'm saying 0 and 5. And I'm putting that dot on the x-axis itself. Okay, so I'm putting this dot here, and then I'm going to put 5. Okay, this is the 5, and of course the y value is 0. That's where it must always start. Okay, so that's the first one. Always remember that one always goes with 0 as the y. Then here, the next x value we're going to have is going to be the 15 and the 20. Okay, those go together like that. So 15 and 20. 15 would be in between this. So I'm going to go 12, 14, in between would be 15, and then 20. I don't actually have to write these numbers. They can't see. Okay, so 15 and 20. This is counting in tens probably. So 10, 20. Okay, so we're in between here for 15, and then 20 is just going to be 2 up. So that's where that dot is going to be. I'm not going to put these numbers. It's not really necessary. Okay, next one is we have the 25 and we're going to take 45. Okay, so 25 and 45. Okay, 25 is just in between here. So 1, 2, and in between there is your 25. Then we're looking for 45. Since this is 50, it's just going to be halfway. So halfway, this is 50 here. Halfway in between here, kind of there in the middle. And then we have the 35, and we're taking that with 105. So 35 and 105. 35 is in between here. 105 is going to be, so here's 100. So halfway, just a little bit higher. Since this is the 100 mark, we're going to say just a bit higher than that. So just maybe here. Okay, so halfway in between. Okay, that is the next one that we have. And then we have 45 and 195. 45 and 195. That will be here. 45 is in between here. Then 195, that's going to just be, we have 150. Then 190 is going to be just below the 200. Okay, because that is counting in tens. So here we just go move up and reach the 200 mark and just go a little bit below it and just mark that in between. Okay, so there. Then we go for 55 and 250. So you get how it's working now. 55, 250. 55 is in between. 250 is already here. So we're just taking the in between of that. So here, 55 and 250. Okay, and then we're going to have 65 to 90. Okay, 290 is an easy number to get. So here's 300. 290 is just one below it. So 65 would be in between and 290. So we have 290 just here on that line. And then the last one, which of course is 75 and 320. So 75 and 320. 75 in between, 320 would be just 10, 20. So 2 lines up here and in between these two. So somewhere here on that dot, on this line. Okay, so there is our ogive. And now you just have to join it. Okay, so it doesn't have to be perfect. It's going to kind of look like a little bit of a curve, like an S. So we're going to join it. It is just from here. We just join all of these points, move down. Okay, and there. Okay, so that's the ogive that we have, and it is drawn. That is for 4 marks. Okay, moving on to the next question. They say, use the cumulative frequency graph to determine the median age of the people who attended the music concert. So we're going to use that graph that we just drew to determine the median age. So to find the median, very simple. All you're going to do is, because the median is speaking about halfway of the data, we're going to say, to find the median, first of all, of course, the position of the median, we will say a half multiplied by the total number of people. Okay, so that would be n, the frequency, the total frequency. Now, the total frequency, or the total number of people in this data, is 320. We already know that from here. There's a total of 320 people. So you will notice it's always going to be the total that you found in the cumulative frequency. So that is 320, and let's see what that gives us. Okay, half of 300 is 150, half of 20 is 10, so that's 160. Okay, so that is the position. That's where the person is. Now we actually have to find them. Remember, I only took the number half and I multiplied it by 320, which is speaking about the number of people. Okay, so this right now, you will go to the frequency, the cumulative frequency, and we're going to look for 160 there. So on your graph, we're going to the cumulative frequency part, and we're going to look for 160 here. So 160 here, here's 150, here's 160. So I think on this it'll be easier, because just in your exam, make sure you use a ruler. So here, I'm just going 160, and I'm going to draw a line until I touch the curve. So I touch the curve over here. The minute you touch the curve, you start moving down. So if you move down, you see that this is where we land. So it's just past 40. Let me estimate round about where this is going to be. So if this is, okay, so looking at this, it's around about 41, 42. It could also be my fault because of the way I drew the curve. Maybe I didn't really curve it well enough, because I can even see a little bit of a hunch here. It should have at least go like that. But anyways, okay, so what we get for 160, if you say that the median, okay, the median age, so the median age, as we can see, we got around about 41 or 42. I'm just going to say approximately is approximately 41 years. Okay, because this is age. So this would be the median. So this is the median age that we have. We have people that are 41 years old. Okay, that is the last question for question 2. It's a total of 8 marks. Then we move on to question 3. And now we're on question 3, and question 3 says, in the diagram, the equation of line AF, so AF, that equation is y is equal to negative x minus 11. Okay, then B, a point on the x-axis, so here's B, is the midpoint of the straight line joining A and C. So here we have A and C. This is the midpoint of that line. Then they say the angles of inclination AF, so the angles of inclination of AF and AC are alpha and 63.43 degrees, as you can see there. And then we have that AF cuts the x-axis in E. So it cuts the x-axis at E here. Then D is a point such that DE is parallel to AC. So here we have 2 parallel lines as well. Okay, the first question, we have to calculate the value of T. So as you can see, T is the y value of this point A, which is on the line with the equation y is equal to negative x minus 11. So all we have to do is, this is your x value, negative 1. This is your y value. And because it lies on this line, we're going to substitute it into this. So since T is the y value, in place of y, I'm going to say T is equal to, and we'll say negative and x is negative 1. So negative bracket negative 1 and then minus 11. Okay, so this will give us T. So we can say T is equal to negative 1, and that becomes a positive 1. So 1 minus 11, because it multiplies in. And so we have T is equal to 1 minus 11, negative 10. Okay, so there we go. That is the value of T. And then we move on to 3.1.2, and they want you to calculate the size of alpha. Okay, so let's look at alpha. Alpha is over here, and we can see it is the angle of inclination of the line AF. Okay, to find an angle of inclination, you just need the gradient of that line. So of this line, the gradient is negative 1, as we can see. So we know the gradient of AF. Gradient of AF is equal to negative 1. To calculate the angle of inclination, we use the formula tan of theta, but in this case, I'm just going to call it alpha, is equal to whatever your gradient is. And our gradient is negative 1. Okay. So also remember, the gradient is negative. So angle of inclination is speaking about the angle that is formed by this line and the x-axis. As you can see, this is an obtuse angle. So there's something we need to add here when the gradient is negative. So to solve for alpha, try to leave alpha on its own by taking tan over. So when you take tan over, it becomes shift of tan. So on your calculator, you're just going to press shift tan, so arctan, and we have negative 1. So this is to find alpha of negative 1. Now, the thing is, this is angle of inclination. If you say shift tan negative 1, you're going to get negative 45 degrees. And that's not going to make sense right now. How can that be negative 45 degrees? But we can clearly see this is an obtuse angle. Okay. So what you need to do so that you can actually get the obtuse angle is you need to say plus 180 degrees. The thing is, it's measuring backwards. It's actually measuring here. It's measuring this little angle. And that's why it's negative 45 degrees. So the size of it is 45 degrees, but it's measuring clockwise. Angles are meant to be measured anti-clockwise. Okay, so you're going to have to say plus 180 degrees so that you can get the obtuse angle. So if I say that and I say plus 180 degrees, I get 35 degrees. So alpha is equal to 135 degrees, which looks perfect. It's an obtuse angle. Okay, so that is alpha. Moving on to the next question. So the next question, 3.1.3, says we have to calculate the gradient of AC to the nearest whole number. Okay, let's look at the line AC. So this line AC, and it's always important when you find something, fill it in. So we know now what that is, that y, that t is -10. Okay, so we need the gradient of AC. Normally, to find the gradient of a line, you need 2 points. But you can see on this line, look at the problem we have. We have 1 point, we have A. B is missing, C is missing. So what else have they given us in order to find this gradient? Well, as you can see, we have an angle of inclination here. Remember the formula that we used to find the angle of inclination? It included the gradient of the line. It's tan theta is equal to the gradient. We're going to use this formula to find the gradient of this line AC. Let's use its angle of inclination. Okay, so we're saying tan theta is equal to the gradient. If we say tan theta equals to the gradient, and we know what theta is, the angle of inclination is 63.43. That's the angle of inclination of AC. So we're going to say tan of 63.43. That is going to give us our gradient. So let's see what the gradient is. If you say on your calculator tan 63.43, so we get, as you can see, they said round off to the nearest whole number. That would be 2. Okay, rounded off to the nearest whole number. So we have the gradient is 2, and that is for 2 marks. Okay, so that is the gradient of AC. Moving on to the next question, we have determine the equation of AC in the form of y is equal to mx plus k. Okay, so to find the equation of AC, we have everything we need. We have a point A, we have the gradient of this line, we can find that. So there's 2 equations to find the equation of a straight line. There's y is equal to mx plus c, or you could use this formula, y minus y1 is equal to m bracket x minus x1. I like to use this because I just feel like it's simpler to find that c value. Okay, it just finds the equation of the line straightforward. So you can go ahead and use the other one, but I'm going to use this one. So in order to use this, first of all, you need a point. The points that we have is A, and the coordinates of A for this line AC is -1 and -10. So we have that -1 and -10, and we know the gradient of AC as well is 2 that we found. So we're just going to substitute this in. This is going to be your x coordinate. It's going to be x1. You see, x1 and y1 are for your points. So this is x1 and that is y1. And so let's go ahead and substitute. We have y minus y1 is -10. So that's like saying minus a -10. And if you multiply that in, that becomes a +10. So I'm just going to already change it from here. It's going to become a +10 when you minus minus. It's equal to, then we have the gradient, which is 2. So 2 bracket x minus, and as you can see, we have a -1. So as you can see, the same thing will happen. Negative and a -1. You multiply in and you get a +1. So I'm going to change that to +1. Okay, so this is what we have so long. Then we're going to FOIL this in. Okay, so over here, what's going on is we have 2x and +2. Okay, that is done now. Then I'm going to take this 10 over, because it's going to come over either ways. -10 now, that's what it becomes. And then we're just left with the y on this side. Okay, this is why I like to use this method, because it just finds the equation straight. So we have 2x and +2 minus 10 is -8. And there we go. So that's the equation of the line AC. Okay, moving on to the next question. Okay, now we move on to 3.3. Okay, so 3.3.1 says calculate the coordinates of C. So let's find the coordinates of C. C is here, one of the endpoints of this line AC. Okay, in C, remember what they told us? They told us that AC, right? The B is the midpoint of this line. The good thing about this is we have the equation of this line now. So the equation of that line is y is equal to 2x minus 8. We already have that. So y equals 2x minus 8. And in order to find C, we have A. We can find B. Since we know B is the midpoint, Then using the midpoint formula, we'll be able to find C. So B, as you can see, is the x-intercept as well as the midpoint. So since it's the x-intercept, we can go ahead and find it by making y equal to 0. That's how you find the x-intercept. So let's find B first. So to find B, we're just going to make y equal to 0. So remember our equation was y is equal to 2x minus 8. We'll just say 0 equals 2x minus 8. Then we can take negative 8 over. And so we have positive 8 is equal to 2x. To solve for x, divide both sides by 2. And so x is equal to 4. Okay, so here we have B. B, the coordinate is really just 4 and 0 because it's an x-intercept. Okay, so now that we have B, we can use this to find C. So 4 and 0. Now remember, B itself is the midpoint of this line. Okay, so because B is the midpoint, we're going to use the midpoint formula. And remember, the midpoint formula just says x1 plus x2 over 2. And we have y1 plus y2 over 2. Okay, so that's the midpoint formula. Now you need to remember what is going to be referred to as x1 and x2 and y1 and y2. That is going to be the endpoint, meaning A and C. Okay, if you use B as any of these x1 and x2, you're not going to find the midpoint. It's not really going to, it's really just going to find like for example, if you used A and B, you're just going to find the halfway point of that. We don't want that. We're trying to refer to this as AC, and B is the midpoint. So this -1, that is going to be your x1. And your -10 is going to be your y1 because this is the first point that we have. Then C. Now C doesn't actually have a coordinate, so what we're going to call it is x and y. And so this will be your x2 and your y2. So that's how we're going to use that. Okay, so here I'm just putting down the formula. I'm saying that the midpoint of AC is going to be, okay, and that's our formula. And so now we're just putting down what we have. Now that midpoint is equal to, so the x1 that we have here, okay, we have -1 plus x2, which is x. So -1 plus x, and then over 2, and then we have -10 plus y over 2 as well. Okay, so just using it as the endpoint. -1 plus x over 2 and -10 plus y over 2. Now, remember, we're trying to find the midpoint of AC. But the thing is that we already know what the midpoint of AC is. The midpoint of AC is B. It's right in the middle. So that 4 and 0. So we're going to put that in place of midpoint of AC. That is the 4 and 0. So you see, this calculation is meant to find the midpoint of AC. This is the x value of the midpoint. This is the calculation for the x value of the midpoint. That is the y value of the midpoint of AC, and that is the calculation for that. So they represent the same thing because this is just us calculating this, but we already know what the answer is. So what you're going to do is we're going to take the x value and the x value and equate it. So we're saying that 4 is equal to, and we're equating it to this, -1 plus x over 2. And 0, the y value, is equal to, we have -10 plus y over 2. Okay, so this is what we have. We just have to solve for x and y. So here to solve for x, you see we're trying to get to there. The 2 is a problem, so we need to get rid of this 2. Since this is being divided by 2, to get rid of it, you would multiply by 2. But what you do on the one side, you do on the other side. So I'm just saying times 2 and then times 2. Okay, so that will give us an 8 here is equal to, and here the 2 on the numerator and denominator would cancel. Then we're left with -1 plus x. Then we're taking this -1 over, and so that is an 8 plus 1 is equal to x, and so x is equal to 9. Okay, so we have x, and now to find y, we'll do the same thing. There's a 2 on the denominator. To get rid of it, you multiply both sides by 2. 2 times 0 just stays 0 is equal to, that cancels, and you have -10 plus y. Take the -10 over, that will give you a +10, okay, as y. So we can say that y is equal to 10. So there, that is the x and the y value of C. Okay, so C, the coordinate of C is really just 9 and 10. Okay, that is our final answer. Okay, moving on to the next question, we have 3.3.2. So they want us to find the size of the angle FED. So FED. E is the focal angle. So we have FED, which we would draw like this, FED. So this entire angle, let me just erase these. We have to find this entire angle over here. Okay, so with these stuff, sometimes there's a bit of construction that you need to do. So let's look at this angle and just see a way that we can actually just find it. Okay, so a piece of this angle, I'm just going to call this E1 and E2. A piece of this angle, we kind of already know how to find. You saw that this actually just measured this angle backwards. So we know the size of this angle when we were trying to find alpha. And we really just found that by saying, remember, when we're trying to find alpha, when we said shift tan, so where was alpha again? Okay, so here, when we said, took this over and we said shift tan of -1, right? When we did that, it gave us a negative angle. I think it was -45. Okay, it gave us -45 degrees. Now that, because it was referring to the line AF, this line AF, it was measuring this angle but backwards. So that is that 45 degrees. Now I'm not going to bother about the fact that it is negative. I'm really just going to take the positive of it. So this over here is 45 degrees. We just have to find this part. Okay, so I'm just going to say to find that little piece. I don't want to call it, I'm just going to call it E1 because it's just a small part. So we found the E1 by saying that tan of theta was equal to -1. Okay, the gradient of that line AF. Then we're just taking tan over, and so that is theta is equal to shift tan of -1. And that would give us -45 degrees. But then you can just multiply it by -1 because we're not really bothered about the direction that was going. We just want the size of the angle. So theta is equal to 45 degrees, or E1 really. So positive 45 degrees. That is that little part. E1 is 45 degrees. And then we have to find the other part of that angle. So we have this first one. Okay. So to find the other part of the angle, this E2, many a times you're going to have to make constructions on this so that you can just see what's going on properly. So what we can do, you see that E2 is being created by the line ED. Okay, so it's being created by the line ED. And as you can see, ED is parallel to something. If lines are parallel, their gradients are the same. So ED is parallel to this line AC. So it means they have the same gradient. Now remember this line AC, we found its gradient, that 1.999. So it was basically 2, right? We know the gradient of AC is equal to 2. So it would mean that the gradient of this line ED is also equal to 2. Okay, so I'm just going to note that down first. Because the lines are parallel, I know the gradients are equal. So I know that the gradient of AC is equal to the gradient of ED. Okay, so that is down already. Now, why am I trying to actually just focus on this line? Well, if we extend this line, we can actually extend it. So I'm just going to extend this line just so that you can see what's going on. It needs to be a straight line. Okay, something like that. So we know that this is parallel to this. They have the same gradient. If you were trying to find the angle of inclination of this line, it's from the x-axis moving up to the line. Okay. Now, because they have the same gradient, their angle of inclination will also be exactly the same. So if this angle over here would be exactly the same as this angle over here, okay, because they have the same gradient. So this is also 63.43. So this is 63.43 degrees. And this is the reason why it is helpful to extend this angle. Look at what we can actually see from this. Now, remember, we're trying to find E2, angle E2. So if we're trying to find this angle over here, let's see what it's being created by. It's created by the x-axis and this other line, DE or ED, extended like that. Okay, this is the reason I'm trying to find out how this angle is being created, because you see, this is the size of the angle, and you can see now we just created vertically opposite angles. What do we know about vertically opposite angles? Vertically opposite angles are equal. Okay, so that's a way that we could have looked at it. So really, from instead of just jumping to this, I only jumped to it because I could actually just see it now. What you could have done is start from E2 and see, okay, how is E2 created? So E2 is created by the x-axis and this. So to understand this more, you could have extended this line like I did here, and then now see that, okay, we have vertically opposite angles. So it means that this itself, E2, is 63.43 degrees. Okay, so now we know E2, so I'm just going to put that down. I know now that, I'm just going to put the line here, E2 is equal to 63.43 degrees. But remember, they want us to find FED. So FED, okay, which is the addition of both angles. So FED is made up of this little E1 and the E2. So we're just going to add 45 and 63.43 degrees, and that will give us that angle. So 45 degrees plus 63.43 degrees. So FED is going to be equal to, and remember, you don't really need reasons. This is analytical geometry. It's not Euclid. And when I add that up on the calculator, I get 108.43 degrees, and that is the size of FED. There are other ways of calculating these, okay, but I like to use the method of finding out what lines create the angle, extending certain lines so that I can understand where these angles appear again because of vertically opposite angles. Okay, so that's it for that question. Moving on to 3.4. And now we are on the last question, and question 3.4 says, G is a point such that EAGC in that order is a parallelogram. Okay, we have to determine the equation of a circle centered at G and passing through the point B. Write your answer in the form of this. Okay, so the equation of a circle. So they've given us the equation of a circle, but they've also told us that G is the center of the circle. Okay, the equation of the circle centered at G. So G, just remember that it's going to have the coordinates A and B. Okay, so that is going to be G's coordinates, whatever A and B is, which we're going to find. And then we also have B is a point that it basically passes through. Okay, so B is already there. I think that was 4 and 0. Let me just confirm. So B is, yes, 4 and 0. So we have these two. So B, 4 and 0. Do we have G? Okay, so G is one of the ones that we have to find. But they're telling us that this shape is a parallelogram. So in that order. So this shape, EAGC, in that order. Okay, so let's draw that shape out first. EAGC. So here's E, A, and so then we're going to have G somewhere, and then C is a parallelogram. Okay, so kind of something like this. We can extend this line. We're going to have EAGC. Okay, since this is the last question, I'm just going to get rid of some information that I don't think is really necessary. Okay, and remember we have C. C is the point 9 and 10. Okay, so we have C already, which is 9 and 10. Since we have this, let's see what they're trying to tell us to find. They tell us that we have a point G, right? And they're saying that this shape is a parallelogram, EAGC. Okay, that is a parallelogram, something like that. So if I just connect it, we have that, and we have this over here. And they want us to determine the equation of a circle, and its center is G, which we don't have, and it passes through B. Okay, so some sort of circle like that. Okay, with the center at G, I know this is not really drawn to scale right now. The center is at G and it passes through B. Okay, so something like that. Okay, if we have to do that, for now I'm just going to erase the circle. We need the center of the circle. We need the center of the circle and at least 1 point on the circle. We have 1 point on the circle. It's B because the circle passes through B. So how do we find G with the information they've given us, since this shape is a parallelogram? So how do we actually find the coordinates of G? Okay, looking at the information they gave us, the coordinates of G, we don't have E, we don't have G, although we do have these two. Okay, so there's something here now we can use. Because we have E, A, G, C, those are the points on this parallelogram, right? The 4 points that we have. It would mean that this AC is a diagonal. Okay, and since this is a parallelogram, something we know about diagonals in the parallelogram is that they bisect each other. And really what that means is when something bisects another thing, it's not the same as it intersecting. To intersect just means to cut through. But when something bisects another thing, it means, like if I have this line and I say this new line I'm going to draw bisects this line, it means it actually cuts this line into 2 equal parts. That's what it means to bisect. Okay, so if the diagonals bisect each other, what it would mean is that we have here AC, the other diagonal, which would be EG, right? So EG, it's also going to bisect AC. And basically, they're going to share a midpoint. Okay, now already from this, I can already see something is weird about this information. We already know that the midpoint of AC is B. So it means that the midpoint of EG should also be B. So this line, okay, this point G actually, it's clearly actually on the x-axis because see, E all the way to G is one of the diagonals we're going to have. So this is actually how this should have been drawn. So we're going to have G somewhere maybe here. And if we extend the point, we're going to have this. It's on the x-axis. Like let's say that's G, and then it's going to connect like that. Okay, so basically something like that. So you see now EG, let me just say G, EG is a diagonal and AC is also a diagonal, and we have B as the midpoint of both of them because it's a parallelogram. The diagonals bisect each other, so they share a midpoint. Okay, so this is the 4 and 0. Okay, so with this information, we can use the midpoint theorem. Since we already have this, we have these two endpoints, we have the midpoint of it. We just have to use the midpoint formula, not theorem, the midpoint formula on EG, okay, since we already know the midpoint. So for us to use that, we don't have G, that's just X and Y so long. But we can find E. Okay, we may not have E right now, but we actually can find it. I'm not sure, do we actually find E? Let me just check. Okay, no, we don't have E. So we can actually find E. You see E, it's sitting on the x-axis. So it is the x-intercept of this line that it is on. And we have the equation of this line. So we just have to find the x-intercept. Now that I'm saying that, I feel like we found this already. But okay, let me see. So the x-intercept, when you want to find the x-intercept, you just make y equal to 0. Okay, so that's all we're going to do here. 0 is equal to negative x minus 11. And so let's solve for x. We can just take this negative x over. Positive x is equal to negative 11. And so it means that E is just negative 11. And because it's an x-intercept, the y value is 0. Okay, so we have E now. And now that we have the coordinates of E, negative 11 and 0, we can use this to actually find G. We have its midpoint. We have the midpoint of the line EG. The midpoint of that line is point B, which is 4 and 0. So we're going to use the midpoint formula. Okay, to calculate the midpoint of this line EG, we would say x1 plus x2. So this will be our x1. This will be our y. This is the y value. So y1. And then this one over here, the other endpoints, because we want to find the midpoint of EG. Okay, so that is x2 and y2. So we're going to use that, but we already have the midpoint, kind of like we did already in this one of these questions here. Okay, so let me put down the points that we have and let's just calculate that. Okay, so we have E, we have G, and the midpoint of EG itself is that coordinates B, okay, which is, of course, 4 and 0. So let's use the midpoint formula. So that says x1 plus x2 over 2, so midpoint of EG. Okay. And then y1 plus y2 over 2. You don't necessarily have to put an equal to here because this is actually a point, but it doesn't matter. Okay, then we're saying the midpoint of EG is going to be, and so x1 is going to be this. We have negative 11 plus x2, that is x2, plus x over 2. And then we have y1, which is, of course, the 0. So 0 plus y2 over 2. Okay, now in this formula, this is just to find the midpoint of EG. We already know what the midpoint of EG is. It is 4 and 0. It's that coordinate of B. So in place of midpoint of EG, I'm just going to put 4 and 0. And like before, again, the logic behind this is that this is the calculation. This is the formula or the calculation for the midpoint of EG. But this is the midpoint itself of EG. So we can just say that this x value would be equal to this x value because it's really talking about the same point. This is calculating the point. This is the point. And then this is the y value and the y value. So we're going to equate it like that. So we're making the x equal to the x. So 4 is equal to negative 11 plus x over 2. And we have the y. 0 is equal to, 0 plus y2 is just going to give you y2. So I'm just going to say, I didn't have to say y2. I could have just said y. Okay. Because the y2 was y. Okay, so plus y over 2. Then we just have to solve. So here, we need to get rid of the 2, multiply by 2 on both sides. We have here 8 is equal to negative 11 plus x. And then we're going to take that over. So 8 plus 11 is equal to x. X is equal to, and that's going to give you a 19. Then the y value, just going to get rid of the 2 by multiplying both sides by 2. 0 times 2 still stays 0. And so y is equal to 0. Okay, so because that cancels. So this is what we have now. We finally found the coordinates of G, that endpoint. We know what that is now. So G finally is the point 19 and 0, which makes perfect sense. It is an x-intercept as well. It's on the x-axis. And remember in the information, they told us that this was the center. So G is the center of the circle whose equation we have to find. So this is the center of the circle. And what else did they tell us about this? They also told us that the circle passes through the point B. And we know what B is. So all we have to do now is actually just find the equation. Okay, but let me just make some space. Okay, so we're just going to go ahead and take this equation of a circle. So x minus a all squared plus y minus b all squared is equal to r squared. Because this is the circle center, your value for a and b would be the 19 would be the a, the 0 would be the b. And then, since we have the center, we also remember that B is a point that the circle is going to pass through. So B, we're going to use this as a point we're going to substitute into this equation of the circle. We're going to substitute B, which is 4 and 0, and this will be our x and y coordinate. Okay, so let's go ahead and do that. We're going to have, in place of x, we're putting 4. So 4, then minus the a value is 19, all squared, plus the y value here is 0, and then minus the y value here is also 0, all squared is equal to r squared. Then we can just put this all onto the calculator. You see, that's going to be 0. You don't need to put that part. So just 4 minus 19, all squared. And you see what that gives us? It gives us 225 is equal to r squared. I'm not going to solve for r because I just want the equation of the circle. So if I'm concluding, right, you're going to say x minus, and then the a value, okay, we're going to put that in there because that needs to be filled in. A and b needs to be filled in. X and y can be left empty because this is the equation of a graph. It's a circle in this case. Okay, so a minus 19 all squared plus, and then here we're going to have the y minus 0 all squared, okay, because that's our b value, is equal to what is r squared. We just found that, 225. So 225. So as you can see here, y minus 0, that's just going to give you y. Okay, and so that all squared is just y squared. So this is the equation of the circle at the end of the day. Okay, so that is the final answer there. So yeah, that question was quite long. It's about 4 marks. Okay, so that's how we work that one out. And now we move on to question 4. Okay, so now we're on question 4, and question 4 says, in the diagram, the equation of the circle centered at n, which is negative 12 and 5, is x squared plus y squared plus 24x minus 10y plus 153 is equal to 0. Okay, so they already gave us the center, but this is the equation of that circle. Then they say the equation of the circle centered at M, the bigger circle, is this. Okay, then they tell us PS and PR are tangents to the circle centered at M. So here, these two are tangents. And then we also have at S and R respectively, PR is parallel to the x-axis. So these two lines are parallel. Okay, x-axis and that. And then we have K, which is negative 17 and negative 5, is a point on PS. Then they also tell us that the straight line joining N and M cuts the smaller circle at T and the larger circle as S. Okay, so just intersections here and there. The first question is to write down the coordinates of M. Okay, so M, the coordinates of M, that is the center of the bigger circle. The center of the bigger circle, let's see. They told us, what did they tell us about the circle? The equation of the circle centered at M is this. Okay, so we have its equation. When you have the equation of the circle, okay, this will stand for your A. It's really minus A and minus B. Okay, so because of that, when we're going to find A and B, so M, the coordinates of A and B, you're going to always change whatever sign is here. Okay, because of that x minus A, because you're subtracting it. Okay, so instead you're going to have a negative 6, and your B is going to be, since it's positive 3 here, it's negative 3. So that's how we find that. Okay, because it's really just x minus the negative 6. That's why this became an x plus 6. So you see this minus A, here's the minus, and that is the value of A, that negative 6. Okay, likewise with the B. Okay, so that's the first question in question 4. Next question says, calculate, so 4.2.1, the length of the radius of the smaller circle. So we need to find the length of the radius. Okay, so let's look at the equation of the smaller circle that we have, because the radius is always that last number at the end. The equation of the smaller circle is this. They said the one centered at N, okay, this is the equation. So you see, we have to first complete the square, put it in standard form so that we can actually see the radius. Okay, so let me put this down first. Okay, and this thing is only blurry for question 4 and 5. After that, it will be clear again. Okay, so we have this, and we basically just have to complete the square on this. When you complete the square, we're going to, first of all, let's put it in the right order. The x's need to go together and the y's need to be together. So this is actually just x squared plus 24x. Then we have a positive y squared, so plus y squared minus 10y. Then the constant needs to go over, so the number without a variable. So is equal to, that will become negative 153. So this is what we have so long. Then we're going to work through it like this. We say first x squared plus 24x. Then we're going to take the coefficient of x, which is positive 24. And we're going to multiply by a half, or say what is the half of this. Okay, so you can multiply by a half or say the half of this, and that will be a positive 12. So what we're going to do is we're going to add by the positive 12 and then square that number. Okay, then we continue. We have plus, we have y squared minus 10y, and we're going to do the same thing for the y. We'll take the coefficient of y, which is negative 10, and we half it, or you multiply by a half. So half of negative 10 would be negative 5. So you're going to add by negative 5 all squared. Then is equal to negative 153. And because this is an equation, you want it to balance. You want to not change its value. We're just changing the way it looks. What you do on the one side, you must do on the other side. So what we did on this side was we added positive 12 all squared. And again, we added negative 5 all squared. So we need to do the same on that side. Okay, so this is what we have. Okay, now we have to just simplify this. We're going to have, because we have x squared here and we have a positive 12, because they both have squared on top of it, we're going to put them in one bracket. And so we're going to have x, and this 12 now is positive. That's why we're going to have a plus 12. The plus is not coming from this plus over here. It's coming from the fact that the 12 is positive. Okay, now the logic behind this is that if you actually take this trinomial as it is here, the full value, even that, and you factorize it, you actually will end up with that. So it's this, and then the squareds go on top, all squared. Okay, and we're going to do the same thing with the y. So plus, you see that the y has a squared and this also has a square, so we're going to put it in a bracket, and the squared from this y and from that goes here, all squared, and then we're saying we're dragging down the y, and we're dragging down what's inside this bracket, all squared, which is a negative 5. So we say minus 5, okay, all squared. Let me actually just pull that closer. All squared then is equal to all of this number. Now, at least it's all numbers, so you can just put this onto the calculator. And then we get 16 for all of that, so 16. Okay, the question was the length of the radius. The length of the radius, we're going to find that from this part. Remember, this is in the form of x minus a all squared plus y minus b all squared is equal to r squared. So this part is the r squared. So we're really just saying r squared is equal to 16 because that's what r squared is. And we're going to square root to find the radius. So r is equal to just 4. Now here I'm not going to say plus minus really, because a radius is a length. It can never be negative. So even if you walk backwards, you cannot say I walked negative 2 meters. No, you covered 2 meters only. Okay, so it's just a positive 4. So 4 units. Okay, so that is what we have as the radius. Now moving on to the next question. Okay, the next question, 4.2.2 says, we have to determine the length or calculate the length of TS. Okay, let's look for TS. So TS, as you can see, is just this little line here from the circumference of the smaller circle to the circumference of the bigger circle. So what is the length of that line? Okay, so the way we can find this length is, remember that we already have M. So M is the point negative 6 and negative 3. So put that down, negative 6 and negative 3. Now, since we already have that, look at how we can find TS. Think about it like this. If you took the distance all the way from N going to M, right? And then we subtract by the distance from N to T and the distance from S to M, which of course are the radii of these circles. So the radius of the smaller circle is the NT. If we do that, we're actually going to find that little TS. So it's this entire length, that NM. And if we subtract that by this length over here, NT, minus this length over here, SM, you'll be left with this little piece, TS. So that's what we're going to do. Okay, so to find the entire length of NM, we're going to just have to find the distance of NM. And you see we have both points already. Okay, so let's find the distance of NM. m, we're going to take that distance, and we're going to subtract it by this little distance of nt. Now, nt is just the length of the radius, okay, of that circle. From n to t is to the circumference. That is one radius. Then we're going to subtract again by this little part, sm. By sm, the other radius. And this calculation basically will give us ts. That's how we'll form ts. Okay, so let's go ahead and do that first. Okay, so with this, we can actually separately just find nm. You can do that. There's nothing wrong with that. So nm, and we're going to find that. The formula for the distance, okay, of a line is the square root of, then you say x2 minus x1. Even if you said x1 minus x2, it will work. Just stay consistent with the y's as well. Also say y1 minus y2. Okay, so I'm saying x2 minus x1 all squared plus y2 minus y1 all squared. Okay, and I'm just going to use the coordinates of n and m. Okay, so these are the coordinates that we have. So we can go ahead and say, we're saying square root of, so I'm going to just say -6 minus -12. So that is -6. Remember, minus -12 just becomes a plus 12. Okay, so it's just -6 plus 12 all squared. Then we have y2 minus y1. So this is y2 minus y1, which is going to be, so plus. Then we say -3 minus the 5, minus 5, all squared. Okay, so you can just put this onto the calculator and let's see what we get. So we get nm is actually equal to 10. So nm is equal to 10 units. Okay, so we know nm. Now all we have to do is find nt and sm. Okay, and those ones are actually quite simple to find. First of all, so nt is the radius of the smaller circle. You see the radius of the smaller circle, since this is the formula for the smaller circle, and now we already put it in its standard form. We already found the radius of that. That was 4 units. So from here to here, from nt, that is only 4 units. So we're going to say, okay, we have that one as well. So we're really just saying that ts is equal to, that is 10 units, nm, then minus 4 units for nt, and then minus sm, okay? Now, what is the length of that? The bigger circle, the radius is ms, right? And its radius, we already have the equation of it. Look at the equation here, okay? And as you can see, we have 25 here. That stands for r squared. So in order to get r, okay, or the radius of that, you're really just going to say that that r squared is equal to 25, and we're going to solve for r. So to solve for r, we'll have to square root both sides, and so r is equal to 5 units. So now we know what ms is, or sm. That is 5 units, so minus 5 units. Okay, so what is this? 10 minus 4 is 6, and then 6 minus 5 is 1. So this ts is only 1 unit. Okay, that is the length of that, and that is all for 4 marks. Okay, so that is that, and moving on to the next question, 4.3. So 4.3 says determine the equation of the tangent PR. So let's look at that tangent, the equation. So we need to find the equation of this tangent PR. Now remember, like I've already put here, these are parallel. They said that this line, this tangent, is parallel to the x-axis. What that means now is that this is a horizontal line. You see, the equation of vertical and horizontal lines, this is how they work. If a line is horizontal, all you have to do is this. You have a horizontal line. To find the equation, you're going to first find out what number does it pass on the y-axis. Of course, if it's horizontal, it's going to cut the y-axis. And so its equation will start with y is equal to, and then you say whatever number it passes. Y is equal to that. Okay, that's the equation of a horizontal line. On the other hand, a vertical line, you look at which axis does it cut through. It cuts the x-axis. So it will start with x is equal to whatever number it cuts through. Okay, that's the equation of horizontal and vertical lines. So in this case, we have this line PR, it's horizontal, but we don't know, we cannot really see, because if it's extended, of course, we cannot really see what number on the y-axis that it's cutting through. So we need to actually just find that y value. Okay, so what can we use to find its y value? If we look at this, to find this y value, because I just want to know what is the y value belonging to r and of course p. So what is that y value? Well, we know what the radius is. We know what the coordinates, okay, of this center, is. We know what this is. So since we know that this point M, right, is -6 and -3. See, look at this. -6 is the x value. That is -6 over here. -3 is the y value. So we know this y value is -3. Another thing we know is that if you draw a line from the center of the circle to the circumference of the circle, in this case, this line is intersecting the tangent, okay, that this will be the radius of the circle. And we know what the length of this radius is. It's the same as ms, okay? Ms, we already found that. That was 5 units. Remember, that was from here, okay? We already know the radius of SM or ms is 5 units. So it would mean that the radius of mr is also 5 units. So think about it. Here, the y value was -3. This distance is 5. From here to here is 5. But notice we are moving down. When we are moving down on the coordinates, we are not going to add, we're going to subtract because we're moving down. So we're saying we have -3 here and we just have to move down by 5 units. Okay, so -5. Move down by 5 units and we'll get what that value is. So -3 minus 5, that will be -8. And that's how we find that y value. Okay, so I'm just going to put that calculation there because it doesn't seem like there's much calculation to do. So I knew that we had the point M, which is -6 and -3. And so to find the y value, basically, so that was specifically the y value of r and p, of course, but the y value of r, we said -3 and then moved down by 5 units because that's the length of the radius. And so the y value of r is -8. Okay, remember they just want the equation of the tangent, and that tangent is a horizontal line. So remember what I said about horizontal lines. To find the equation, you just check which axis does it cut. It cuts the y-axis. So it will start with y is equal to. At what number does it cut the y-axis? At -8, because we found out what that r's y value is. So y is equal to -8. And that is the equation of that tangent. So you can therefore say y equals -8. Okay, so that is 4.3.1 done. Okay, moving on to the next question. Here in the next question, we have 4.3.2. They say that PS, we need to, determine the equation, of the tangent PS in the form of y equals mx plus c. Okay, let's look at PS. Let's also fill in what we have. We know now r, well, do we know the x value? Yes, we actually do know the x value of r, funny enough. We know the x value of r because I am taking from the center of the circle, and this is a perfectly vertical line, and it's intersecting, and we know it's perfectly vertical because this is a tangent, this is a radius. The tangent is always perpendicular to the radius. Okay, so because of that, we already know now that the x value, so the x value here is going to be the exact same x value here, because look at it, they're in line with each other. If this is -6 over here, the x value right down here, because this is a perpendicular line, is also going to be -6. And now we also know its y value, which is -8. Okay, I'm just filling in all the things that we have already found because it usually helps. Then P, we don't really know its x value, but we do know its y value because you see it's a point on this horizontal line. So its y value is also -8. Okay, this is what we know so long, and they want us to find the equation of the tangent PS. Okay, equation of the tangent PS. Let's see what we have. In order to find the equation of a line, you need the gradient and then you need one other point. Good thing we have a point here, K. We have point K. And now we need the gradient. So how do we find the gradient in this one? Okay, so if you look along this line, PS, you see we don't really have the full coordinate of P. If we had this X value, this would be so easy to find. We'll just use that and that. We'll find the gradient and basically find the equation. But unfortunately, we don't have this. But if you look along this line, you see we also have S, but we also do not have that coordinate as well. Let me just erase this. I don't think that will be helpful. Okay, so what else can we use? Remember how I said here that MR is going to be perpendicular to PR because this is a radius and this is a tangent, and the radius is always just perpendicular to the tangent at the point of contact. Well, that would also apply here. So from M to S, and then you have this PS as a tangent. So this would also be perpendicular as well. Okay, so let me actually just put that down. So I'm saying that MS is perpendicular to PS. Okay, so we're going to use the rule of perpendicular lines. So we may not have this gradient. We have 1 point, which is good enough. But we know now that this line PS is perpendicular to this line MS. And you can see now from M all the way to N, that's just an extension of the line MS. Okay, so of course the gradient of MS is exactly the same thing as the gradient of MN. So what we can do is find the gradient of MN and then use the rule of perpendicular lines to find the gradient of PS, since these two lines are actually perpendicular. So let's find MN. Let's find that gradient. Okay, so I'm going to put the coordinates down and let's find it. Okay, and let's find the gradient of this line first, then we'll be able to find the gradient of the one perpendicular to it. So the gradient of MN is going to be equal to, of course, it's the y2 minus y1 over x2 minus x1. And so we're going to take y2 as this, so 5 minus y1, so minus negative 3, which becomes a plus 3, over, and then we have negative 12 minus negative 6, which becomes a plus 6, so negative 12 plus 6. Okay, so you can put this onto the calculator and let's see what the gradient of MN is. So you see the gradient of MN is negative 4 over 3. So now that we have that gradient, this is what we're going to use, the rule of perpendicular lines. If we want the gradient of PS, which we need to find the equation, we know that this is perpendicular to this. So this means that the gradient of PS multiplied by the gradient of MN is going to give you negative 1. So MN is going to be equal to negative 1. We're going to use this rule. Okay, so I'm just going to write on the side. So I'm saying, putting that rule down. Okay, and so we don't know the gradient of PS. We want to find that. Saying the gradient of PS multiplied by the gradient of MN is negative 4 over 3, which is equal to negative 1. And now we just have to solve for this. Okay, to solve for gradient of PS, you see that it's being multiplied by negative 4 over 3. So we want to leave this alone. Since it's being multiplied by this, to get rid of this number, we have to divide. Okay, so we're going to divide, but because this is an equation, what you do on the one side, you must do on the other side. So divide both sides by negative 4 over 3 to get rid of it. And this is what we're going to get. You can put that on your calculator, but something you will notice about this when you divide negative 1 by a number or a fraction, so it's negative divided by negative, which is positive. What will happen here is the numerator and denominator just swap. So that's just 3 over 4. So this is our new gradient. The gradient of PS is 3 over 4. Okay, and now to actually find the equation of this line, PS have become very simple now. We have a point on this line, K, which is negative 17 and negative 5. And we can just use that point now to find the equation of this line. So I'm going to use that formula, y minus y1 is equal to the gradient, bracket x minus x1. Okay, let me put the coordinates of K here. Okay, so just remember the x1 is this x value, so that's x1. The y1 is that y value. So we're saying y is minus, okay, y minus, and then the y1 is negative 5. So you're saying minus negative 5, which will become plus 5, is equal to, your gradient is 3 over 4, multiplied by x minus negative 17, which will become plus 17. So you just have to simplify this. Okay, so let me just take it to the other side. Okay, so we're saying, I like to start here because that will go over anyways. So we have 3 over 4 multiplied by x, and you have to multiply by that. So we're distributing that. So we have 3 over 4x. If we say 3 over 4 multiplied by 17, that's going to give you 51 over, so positive 51 over 4. Then multiply that out. This 5 needs to come over. So I'm taking that over, and it becomes a negative 5. What's left on the right-hand side is just the y on the left-hand side, I mean. So simplify this. Y is equal to, we have 3 over 4x. And then what is positive 51 over 4 minus 5? So minus 5, and that gives you a 31 over 4. So it is a positive 31 over 4. And so that's what we get. That is the equation of the line PS. Okay, so there we go, in the form of y is equal to mx plus c. Moving on to the next question. So the next question, 4.4.1 says, we have a quadrilateral PSMR. It's drawn, and we have to calculate the perimeter of it. So PSMR, let's just see what that's going to look like. Okay, so this is this PSMR. Okay, let me just highlight it. Okay, so we need to find the perimeter of this quadrilateral. The perimeter of this quadrilateral, all you have to do, it's perimeter, it's not area. So you don't have to start thinking, what kind of shape is this? You don't really have to even bother about that. All you have to do is take all the sides that you have and add them together. That would be the perimeter of the shape. So from that, we see that we're going to have to find what PS is. So from P to S, what is that length? From S to M, so plus SM, then plus MR, and then of course plus RP or PR. And that will give us the perimeter. Okay, so let's see how we can actually find that. Okay, so PS. To find the length of P to S, we would need to have the coordinate of P and the coordinate of S. Okay, looking at the coordinates of P, we know the y coordinate. We don't know the x coordinate, but we actually know the equation of this line. In the previous question, we found the equation of this tangent PS. So if this is the y value belonging to this x value, let's just take that equation, and in place of y, we're going to put negative 8, and it's going to give us the x value belonging to this. Okay, so remember, here is PS. The equation of PS is this. And to find that, let me just put this on the side. This is just the calculation of it. Okay, so this is the equation of PS. And remember, we have that P point is x and negative 8. So in place of y, we're going to put negative 8. So negative 8 is equal to 3 over 4. We don't have x, plus 31 over 4. Okay, solve for x. Take this over. And so we have negative 8 minus 31 over 4 is equal to 3 over 4x. What is negative 8 minus 31 over 4? That gives us negative 63 over 4 is equal to 3 over 4x. Then to get x on its own, we divide both sides by 3 over 4. And let's see what we get. So x is finally equal to this divided by 3 over 4. So I'm going to just say equal to divide by 3 over 4. On your calculator, you can just say divide by 3 over 4. It will just work. Okay, you see we get negative 21. Okay, so that is the x value, negative 21. So it means the point P is negative 21 and negative 8. So we have point P now, negative 21 and negative 8. Let me put that down. Okay, so let me just put this down, negative 21, negative 8. Okay, we have P. We need to find S. To find S, we have PS. We have the equation of that line. We don't have the equation of NM because you see that PS and NM, they actually intersect at S. So if we find the equation of NM, we can equate it with the equation of PS and we will find that point of intersection. Okay, so guys, at this point, I didn't realize that, you see, these two are tangents. So if they're tangents, it means that you can also apply the Euclid theorem, which states that if we have tangents drawn from the same point, P, basically drawn to the circle, that they are equal. So all I really need to do is find PR. So I'm going to skip this whole thing where I try to find that coordinate of S because it's really unnecessary. And if you notice the mark allocation for that question, you'll see that we're really wasting a whole lot of time. You see, this is only 5 marks. Well, not only, but the work I'm doing is way too much for 5 marks, okay? So I'm just going to jump to the part where we have found PR, and I just need you to remember that PR is equal to PS because this is tangents drawn from the same point to a circle. Then let's also think about the other ones. So SM, right? We also have to find that. We're finding the perimeter of this whole shape. S to M, that is a radius. Okay, it's the radius of the bigger circle, which we already know is 5. Remember from its equation. We have the equation. This is r squared. We square root and we get 5. So this is 5 because it's the radius. That would also mean that MR is also 5. And then you see we have P and we have R and we can find that distance. So now it's just a matter of calculating to find each of the distance. SM is 5. MR is 5 as well. So we have those. So next, let's just find the last one, which is PR. Now, PR, you could also use the distance formula, but it's not really necessary in this question. The reason why is because they told us that this line, this tangent, is parallel to the x-axis. So it's a horizontal line. If you want to find the length of this horizontal line, look at this. We have here, this coordinate here is -6, right, of R. So if we know that R is, I'm actually just going to put down the coordinates because I didn't write down this calculation there. So it's kind of going to be, we know R -6 and 8. So P is, of course, the -21, -8. R is the -6 and -8. Now, I'm not going to actually use this calculation because I don't really see it as necessary in this question. What you can actually just do is, you know that this, the x value, right, is -6. So you have -6 over here. Let me just get rid of some things. So here, this over here is -6, that x value, right? Now look at that. This x value here is -21. This is a horizontal line. It's not like this one where you actually have to use a formula. You literally just have to find out what is, if you have to go from -6 all the way to -21, how far is that? Okay, another way of looking at that is by actually saying -6 minus -21. Okay, it's always going to be right minus left because the numbers on the right are bigger than the numbers on the left. Okay, so I'm going to put that calculation down for this PR. That will give you that length, okay, because we know it's x values. Okay, I noticed I said -2, just -21. So I'm saying PR is equal to that -6 minus -21. And we get PR as 15. Okay, I'm starting to realize why I didn't need to actually do any of these calculations. If you look at this diagram, you didn't need that calculation. This is a circle. This is a tangent. This is another tangent. When you have tangents from a circle, okay, or from a point drawn to the circle, they are equal in length, meaning this PS is supposed to be equal to PR. Okay, so sometimes really just step back and look at it and see, is there easier ways of actually doing this? Because that calculation was unnecessary. We didn't actually have to do that. You could have just told them that they're equal and they would have seen that. But even this is fine. Okay, so do we have everything now? So we have PS, we have PR, and we have, of course, those two radii. Okay, so the perimeter of this shape, let me just copy this because that was the calculation for it. perimeter of this shape. Let's just put everything down. This is a long question. And it's equal to PS. We already know that is 15 units. That's 15. Plus SM. Remember that was 5 units from that circle. The big circle, its radius is 5. Okay, so plus 5. And of course, we already have MR, which is also 5. So 5. That's 5 because they were both the same. They were radius of that circle, radiuses or radii. Plus PR, lastly, is 15. Okay, so what is this going to be? 15 plus 15 is 30. 5 plus 5 is 10. 30 plus 10 is 40 units. So this is what we have. The perimeter of PSMR is 40 units. How many marks was that? That was worth 5 marks. Okay, so of course this step here was unnecessary. You could have just found that easily. So that's what we have. The next question now, last question for question 4. This is the ratio. You need to calculate the ratio of the area of triangle NPS over the area of quadrilateral PSMR. Okay, let's see what this is going to be. Now, PSMR, we have the dimensions of that PSMR. We have the length of it. Now we have to find the area of triangle NPS. Let's look for that triangle. Let's look at that triangle. NPS, okay, from N to P to S. So it's this triangle over here. Okay, so it's this blue triangle that we have here. To find the area of it, to find the area of a triangle, hopefully it's a right angle, you only need the height and the base. So as you can see, since PS was perpendicular to MN, then this is 90 degrees and this is of course also 90 degrees. Okay, so because of that, because we have a right angle triangle, we can treat this part as the height. But look at this height. You see they call this NPS. Okay, the height of this is NS, that full length over there. And then of course we have the base of it, which is PS. We have that length already. Okay, so we just need to find the height and the base. The height of this, since this is NS, how can we find NS? Well, we know what NT is. We know NT is the radius of the smaller circle. The radius of that smaller circle, remember when we actually simplified that, we got a 16 on this side. We found the radius of the smaller circle to be 4 units. Okay, so since we have that, we know what NT is. That is 4 units. Then remember in this question, we actually calculated the length of TS. Everything always adds up. They're never just going to ask you new stuff. TS was the 1 unit. There we go. TS is 1 unit. So you can see now, if that is 1 unit, then from N to S will be a total of 5 units, 4 plus 1. So we have the height. We know the height of this triangle is 5 units. And then we also have the length. We have PS. We did the calculation for that. So to find the area of that triangle, we just say a half multiplied by your base multiplied by your height. Okay, let's go ahead and calculate that. Okay, so the equation is half of the triangle times whatever your base is multiplied by whatever your height is. Okay, and over, we'll find out what that one is going to be. Is equal to half multiplied by the base. We're taking this as PS and the height is NS. So multiplied by PS multiplied by NS. Okay, over whatever that's going to be. And this is a half multiplied by what is PS. PS, we already found the length of that bigger side. PS is 15 units. So multiplied by 15. And we know now NS is 5 units from N to S. Okay, let's now concentrate on, so we have all that. Let's concentrate on the area of this quadrilateral. Okay, what kind of quadrilateral is this? Let's look at this. Let's just look at this quadrilateral. So there's a 90-degree angle here. There's another 90-degree angle here. This is the radius. This is 5 units. And I can erase this. I don't really need this. This is also 5 units. Okay. You see two pairs of adjacent or sides that are next to each other are equal. And we also know that this is equal to this. This shape is a kite. And if it's a kite with right angles. That is a good thing. What we can do is actually take this shape and we can actually split it into two. We can split it into two triangles, two right angle triangles. Okay. And then we can separately find the area of each triangle. But notice something here. You see, the height of this triangle is 5. If you also kind of tilt your head, you'll see that this one, the height is also 5. The base of this is PR, which is also equal to this base. And they're sharing the same hypotenuse. This is the exact same triangle. These two triangles, or what we would say are congruent, it's the exact same triangle. So the area of this triangle will be equal to the area of that triangle. Okay, so I don't know if there's a formula. I'm sure there is a formula for the area of a kite, but you don't really work through that in grade 12. So you can just use this instead. So I'm just going to focus on one of it, right? And I'm going to find the area of that. Then to find the area of the entire shape, I'm just going to say times 2 because it's double of that. Whatever this area is exactly what this area is. So just find one of it and times by 2. Okay, so the area of this first shape is going to be made up from, we're going to say the height is MR and the base is PR. Okay, let me actually just say it as it is the area of triangle PSM and PMR added together. Okay, so you see it's the area of triangle PSM plus the area of triangle PMR, which will give us that. And of course, we know it's the exact same thing. So I'm just going to say it is really 2 times the area of triangle PS. I'm just going to take the lower one, PMR. Okay, so that is the lower one. Okay, so to find the area of that PMR, okay, I'm only saying 2 times because it's double. It's really just, if you add that and that is the same thing. So it's double of it. So the height of this is MR and the base is PR. So we're taking the height as, we're saying a half multiplied by. So this calculation again, half multiplied by, well, 2 first, multiplied by the area of that is made up of a half, multiplied by the base of PR, multiplied by the height of MR. Okay, now we can just find this. So on top, if you like, we can just simplify that. And on top, we get a 75 over 2. I'll just give it as a decimal because it'll be easier to just divide like that. 37.5 over, here we're just saying 2 multiplied by a half times PR. Remember that was 15. We already have those lengths. We know PR is 15 and MR is 5. So multiplied by 15 multiplied by 5. Then you can just put this all onto the calculator. So let's see what we get. So I'm putting a fraction for this full thing. Then we have 37.5. This is going to definitely be double because you see we have the exact same thing here. And we're saying 2 times. So it's probably going to simplify to a half. But okay, we can say over 2 bracket a half. Then we're saying multiplied by 15, multiplied by 5. And so yeah, so we get a half or 0.5. The ratio of it is 1 over 2. That's our final answer. Okay, so that is the last question for that. So as you can see, because this is now 5 units and because we're sharing a base, it ends up being a case where this triangle is really repeated 3 times. That triangle has the same area as this triangle, which has the same area as that triangle. Okay, so that is the last question for question 4. And then we move on to question 5. So moving on to question 5, question 5.1 says, without using a calculator, simplify the following expression to a single trigonometric ratio. So we have this expression and we have to simplify this. Okay, so first of all, please just notice what is going on here. We have first 1, then negative sine of negative theta, then the cos 90 degrees plus theta. These two are being multiplied. So it means that on top, if you look at the amount of terms you have 1, 2 terms on top, and then the denominator, you just have 1 term. Okay, so we're going to solve this term by term. That's how you should always solve expressions. each term should work on its own. So the first term is 1. There's nothing we can really do with 1. So we just leave 1 as it is. And then we have sine negative theta. So how do we simplify sine negative theta? Okay, so there's two ways you can simplify it. You can simplify the grade 12 method or the grade 11 method. Now, I like to use, the only reason why I explain the grade 11 method is because it really helps you understand the whole fundamentals of simplifying trigonometric expressions. You see, we have negative theta. Theta represents an angle. You see on that Cartesian plane, theta lies here. It is all the angles that are less than 90 degrees. That's what it stands for. So technically, this has a size and it's saying negative theta. So whatever that angle is, it is negative. There's a general rule about angles that you need to remember. When an angle is negative, what you need to do is add 360 degrees to it. Okay, so I'm just trying to show you the step-by-step method and how it happened. If you add 360 degrees here to that, you end up with, you have a minus in front, then sine 360 degrees minus theta. And then here you have cos 90 degrees plus theta. This is a cofunction, okay? Remember all the rules of your cofunctions. These are all the cofunctions that we have. It's always going to be either 90 degrees minus theta or 90 degrees plus theta. Okay, so I do actually have a video where I explain cofunctions. Well, it's actually the proof of the compound angle formulas. Okay, and I do explain about that. So you can actually check that video out and that little part just to see that, because I don't want to go too deep into this. Just remember that everything here, if this is a sine, it will change to a cos. Okay, it changes to positive cos theta. This one will change because it's cos, it changes to positive sine theta. This one is sine, so it changes to positive cos theta. But then there's one more, and I see I made a mistake here. This should be a plus because we already had that. Okay, so cos 90 plus theta is the only one that changes to a negative sine theta. And of course, that video does explain why. So you can look at that again. Okay, so I'm just trying to be careful with these stuff just so that you understand why we're using certain rules. I don't want to just assume that you understand how it works. So this, okay, that's the one that becomes a negative sine theta. But you need to remember that this is being multiplied by that term. Okay, these two are being multiplied. So it's multiplied by negative sine of theta. Okay, over. Now look at this one. We have cos theta minus 360. Think about that. That reduction, does that look fine to you? Is that usually the kind of reduction you have in your diagram? The one that had 360 degrees is actually 360 degrees minus theta, not theta minus 360. So if you look closely at this, remember, theta represents an acute angle because we have 90 degrees here and theta here. All the angles less than 90 degrees. So it's saying that acute angle minus 360 degrees. So imagine that was like maybe 45 degrees minus 360. You're going to end up with a negative angle. So you see this case, this is a case of negative angles. And what do you do when you see an angle that is negative? You add 360 degrees to it. So if you add 360 degrees to this, look at what you'll get. Theta minus 360 plus 360. Those would cancel. And you'd just be left with cos and theta. That's all you're left with. Okay. So that's the rule. That's actually what happens. I'm just trying to show you what actually happens. Then we can go on to simplifying. We have 1 minus. Okay, so now if we're simplifying this, we have 1 minus and then sine 360 degrees minus theta. Remember again in the Cartesian plane where we have 360 minus theta, this is the quadrant that belongs to cos. Cos is positive in this quadrant. Sine is negative. So you see, you leave that negative here, but this one now becomes a negative sine theta. Then multiplied by negative sine theta over cos theta. Okay, is equal to, now because these two are being multiplied, the sine, this, and this are being multiplied. So if we multiply these two together, you see that we're going to get 1, and then this multiplied by this, because we still have minus here. This multiplied by this gives you a positive sine squared theta. Negative times negative is positive. So sine squared theta. This minus is coming from here. Okay. Over, that we have cos theta. And this is equal to, and now look at this. you need to remember your identities. Your identities are, we have this rule, sine squared of theta plus cos squared of theta is equal to 1. Now, if you made cos squared of theta the subject, so cos squared theta is equal to, notice that on the right hand side you have 1 still, and you would have to take sine squared of theta over so that this can be left on its own. So this is another one that you have. Cos squared of theta is actually equal to 1 minus sine squared of theta. So we're going to change that. So this is actually cos squared theta. That is what is equal to 1 minus sine squared of theta over cos theta. Then on the top, a cos would cancel with the cos on the bottom, and then you see that your answer is just cos theta, and that is that simplified. So it's not supposed to be that long, but the only reason why I did that is because I really wanted you to understand how that works out. Okay, move on to the next question now. So look at what we're given. We're given that cos of 20 degrees is equal to P. Without using a calculator, write each of the following in terms of P. Okay, so this is basically one of the trig diagrams that you can get. This case, it's a rare case, it hardly happens, but here and there they will actually put it in. So with this, they're telling you that cos of 20 degrees is equal to P. Very different from the other ones that we had. Before, they will always say cos of, or theta, right, is equal to something like 2 over 3, right? But in this case, they're telling you the size of the angle. And when they tell you the size of the angle, this is them helping you to know which quadrant it will fall into. Think about it. On your Cartesian plane, which quadrant does 20 degrees fall into? Okay, that is an acute angle. It will fall in the first quadrant. So it means your terminal arm is going to be here, your radius. And then you're going to have 20 degrees measured here. Then you see, they say cos 20 degrees is equal to P. So it means that we're saying cos is adjacent over hypotenuse. So it means P is your adjacent side. What is your hypotenuse? If you have to put P as a fraction, it is kind of like a whole number. You put it over 1. Okay, that's going to be the denominator of it. So your hypotenuse is 1. And this is how we're going to look at this. So I drew the terminal arm, but remember you also have to draw a line going down to the x-axis, and this line must be perpendicular to the x-axis. Then the adjacent side, so he has 20 degrees. What is adjacent or next to 20 degrees? It will be this side. That side is the P. So that's the value of P. And then our hypotenuse is 1. So that's 1. So you see that here, we just have to find the opposite side. Okay, now I refer to the opposite side in terms of coordinates. This is, because you see, whatever this length is, it's a y value. So I refer to that as y. And of course, this one is r. That's 1. And then this is x, because you see, this number here is an x value. So we need to find y. So to find y, I'm going to use Pythagoras, because this is right angle triangle. So we can say y squared is equal to, so we're looking for one of the shorter sides. So you're going to say is equal to r squared minus x squared. Okay, y squared is equal to, what is our r? It's 1. So that's 1 squared minus, what is x? It is p. So minus p all squared. Okay, and so 1 squared is just 1. So we have y squared is equal to 1 minus p squared. Then you need to solve for y. How do we solve for y? To get rid of this square, we need to square root both sides. So if you square root both sides, you need to remember something. When you square root both sides in an equation, you need to add positive and negative here. The reason why is because if you have 1 all squared and it's equal to 1, right? Let's say we have an equation, x squared is equal to 1. And you square it to both sides and you said, oh, x is equal to 1. Well, that's not completely true. This is an equation. X squared is not the only thing that is equal to 1. And this is not completely true because if you said 1 all squared, yes, it is equal to 1 because we're saying x squared, something squared gives you 1. Okay, but if you also said negative 1 all squared, it will also give you 1. So you see there are two solutions here. And the exponent on the x actually gives you a hint on the amount of possible solutions you have. We have 2 possible solutions here. Okay, so you need to always add that plus minus. Okay, now the reason I only explain this is because new people may be looking at this video. I know I have explained this in previous videos, but then I can't also just assume that you've seen them. So y is equal to, now this is where we decide. You see, we know it's in the first quadrant. And as you can see, look at the y value there. Whatever that y value is, it is a positive number. So we're going to take positive, not the negative. So it's just a positive square root of 1 minus p squared. That is our y value. And let me just move this over to this side. So that is our y value. We have the square root of 1 minus p squared. Okay, our diagram is complete. We have r, we have x, and we have y. And now we can actually solve what they're asking us to find. Let me just make some space here. Okay, so we have the first question, 5.2.1, actually just says we need to simplify cos 200 degrees. Okay, so when you're simplifying this type of angle, look at this angle 200 degrees. Which quadrant does that fall under? We have 0, 90, 180. Then we have 270 here. So you see that 200 degrees is just past 180, but it's less than 270. So it falls into this quadrant. So we need to use this reduction for it. This reduction is 180 degrees plus theta, and it belongs to tan. Okay, so when we're looking at this, we're just going to simplify this. This is going to become, I'm just showing it step by step and how it works. So this is going to become cos of, we're going to build 200 degrees using this. So we're saying 180 degrees plus what is equal to 200 degrees. That's plus 20 degrees. Okay, then if you actually reduce this, using the fact that we are in tan's quadrant, cos is negative in tan's quadrant. So this is going to become negative cos of this angle, the theta, okay, which is 20 degrees. So this is what we have, negative cos 20 degrees. And if you see in our information, you can use it here. You can actually find it here. Find out what cos 20 degrees is. That is, cos is adjacent over hypotenuse. But you could have also just looked at the fact that they told you at first cos 20 degrees is equal to p. So if this is negative cos 20 degrees, then this is equal to negative p. Okay, so that is our answer for the first one. Moving on to the next one, we have sine negative 70 degrees. Okay, so there's kind of two ways of solving this. You can solve this thinking about cofunctions, but also just remember, first of all, that this angle is negative. Okay, so I would always like to show the step-by-step way, just so that you see that things don't just happen because, you know, you just made it happen. There's a step-by-step process. The angle is negative. Naturally, when angles are negative, you would add 360 degrees to it. There's also the shorthand grade 12 method. Okay, you could have also just said, let's measure negative 70 degrees. Because the angle is negative, you would not measure this way, you would measure this way. So we would measure like that, 70 degrees. Now, because it's 70 degrees, it is below 90 degrees. From here all the way to here is exactly 90 degrees. So it means that this negative 70 degrees, that angle would only fall within here. It would not go beyond this line. So which quadrant does it fall into? It falls into cos's quadrant. So cos is positive in this quadrant, meaning sine is negative. So if you were just simplifying this, this would have become negative sine. Then you can just say 70 degrees. See, that's what I meant by this is the grade 12 method. It's actually quicker to do that by measuring rather than adding 360 degrees because the angle is negative and then still reducing it. Okay, so now that we already have this, negative sine 70 degrees. Well, 70 degrees, it's already acute. So how do you actually simplify this? And you see that 70 degrees, yeah, it doesn't have a 20 degrees. So we need to actually change this to become 20 degrees. It needs to have something to do with 20 degrees. So let's change this, and we're going to change this using cofunctions. So what is the cofunction for sine 70 degrees? Okay, with this one, it's because it's numbers. Just think about how the cofunctions work. You only have two types of angles in cofunctions. You have either 90 degrees minus theta, or you have 90 degrees plus theta. Okay. And I'm actually just going to put it in a diagram. Now, please note, this diagram does not exist in real life. I just use it for cofunctions because it works well. Here, I have 90 degrees, okay? This is 0, this is 90, of course, that's 180. This part, I call this 90 degrees minus theta. And I also see it as the first quadrant where everything is positive. The second quadrant is 90 degrees plus theta. And I see this also as the second quadrant where sine is positive. Now, this is how I work. It's only for cofunctions, okay? So we're going to have to think about where would 70 degrees fall into. Is it going to fall in 90 degrees plus theta, which you can see is past 90 degrees, angles greater than 90 degrees, or would it fall into 90 degrees minus theta, angles less than 90? Okay, it will fall here. So because it falls here, look at how we're going to do this. We're going to say, we still have the negative there, sine, and we're going to create 70 degrees using this. 90 degrees minus what gives you 70 degrees? So that's 90 degrees minus 20 degrees. Okay. Then we're going to now finally change it using cofunctions. This diagram helps you to change it. You're going to keep the minus on the outside. But what does sine 90 degrees minus 20 degrees give you? It's the same thing as sine 90 minus theta. Okay. That would simplify to, it's a cofunction. It's first going to change to cos, right? But then you have to think about it. Is it going to be positive or negative? Well, it's 90 minus theta, so it's going to be positive because look at this. In 90 minus theta, you ask yourself, is sine positive in this quadrant? Yes. So your answer, your result is also going to be positive. So it's positive and it changes to cos. And then, of course, you have the 20 degrees. So you see that you have negative cos 20 degrees, like the previous, which is also going to be equal to negative p. Please also let me know if I'm over-explaining things. The reason why is because in trig, I've seen so much matrics who actually misinterpret certain things. And then I don't know where exactly it happened along the lines as they were learning throughout grade 10. But then they confuse a whole lot of things, especially like with that thing that I explained with the sine of negative theta, basically that. So there's a lot of rules that I noticed are misunderstood. That's why I'm explaining like this, but please let me know if it's a bit too much. Okay, and then moving on to 5.2.3. Yeah, I feel like we need more space for this. Okay, we'll see. Sine of 10 degrees. You see, these questions, is very important to actually go through these types of questions. You see this one? Yeah, it's a trig function, diagram. It's a trig diagram, and you should really practice on that. This one, it was bound to come in. They always, like, if they had to do that, there was no way they were going to waste all these marks and not put this type of question. Sine 10 degrees. Okay, very weird one. Now, it's a question that will literally only be asked in metric because in grade 11, you would not know about double angles for you to answer this. For this one, you actually have to use double angles. Let me put down the double angle formulas so that I can show you why I'm saying you need to use double angles. So these are the double angles, right? These 4 formulas. Of course, there is that extra one for sine, that half sine 2a. Okay, but I'm not really focusing on that right now. The thing about this is, look at what we have here. We have sine 10 degrees. Remember how I said that everything has to be related to 20 degrees because this diagram has 20 degrees. So we need to relate everything to 20 degrees. Like we were able to reduce this and get it to 20 degrees. We'll be able to get this to 20 degrees. We need to also find a way to make 10 degrees 20 degrees. So what does 10 degrees and 20 degrees have in common? Well, 10 degrees is half of 20 degrees. If you notice something about what the double angles do, look at what they all do. If you have your cos 2a, that's double of whatever a is. It becomes cos squared a minus sine squared a. Again, you have cos 2a, double of whatever a is. This is the reason I'm going to use double angles, because 10 degrees, double of it is going to be 20 degrees. Okay. So now we have to see which formula can we actually use to actually find this. Okay, so how do we find out which one will work? So for this, let me just try a random one. The reason why I'm doing this is because for you to understand why something doesn't work, you have to actually try it for yourself and see why it doesn't work. Let's say I just pick this random one, or let's take one that is more promising because we have sine. Let's say I was like, okay, we have sine, let me take this one. Okay, I'm not saying that's going to work, but let's just try it. So we're saying sine 2a, but we're relating it to 10 degrees. We're calling a the 10 degrees. So instead, this will be sine 2 times 10 degrees is equal to 2 sine, then we have a, which is 10 degrees, and then cos a, which is also 10 degrees. Okay, with this, you should be able to simplify this expression and basically find out what sine 10 degrees is. Look at how we're going to do this. Sine 2 times 10 degrees is sine 20 degrees. That's not a problem. We can actually find the value of sine 20 degrees because it's 20. In the diagram, we can actually find sine 20 degrees. Sine is opposite over hypotenuse. So you see, this part is okay. We can still find that. Then we have is equal to 2 sine 10 degrees, which is fine. We can leave this here because what we're actually going to do is try and make this the subject of this equation. Then we have cos 10 degrees. Now this is where the problem comes. How do you actually simplify cos 10 degrees? There is no, you see in this diagram here, this is 20 degrees, not 10 degrees. I can't actually say, oh, cos 20 degrees is adjacent of hypotenuse. No, that's not true. Cos 20 degrees in this situation, in this diagram, can be found by saying adjacent over hypotenuse, but not cos 10 degrees. So the problem here with using that one, just because it's sine doesn't mean you need to use it. The problem here is I can't find the value of this. I may be able to find this. I may be able to make this the subject, but I can't find this one. So this rule is not going to work. And something you can do is actually try the other rules as well. So as exercise, go ahead and try the other rules and see which one will work. But now I'm already showing you that the one that will work for this is actually this one. So let's look at this. If you have cos 2 and we have a, right? A is 10 degrees. So 10 degrees is equal to 1 minus 2 sine squared of a, which is 10 degrees. Look at what we can do here. Cos 2 10 degrees, okay, that is going to give you 20. So that's cos 20 degrees. We can find that. We already know what cos 20 degrees is. They told us in the beginning that cos 20 is equal to p. We can find that value. Okay, so we have this value is equal to 1 minus, now you have this. You see, you have 2 sine squared of 10 degrees. This is not a problem. We want to solve for sine 10 degrees. Here, look at your sine 10 degrees. All you have to do is make that the subject. So now this becomes an equation where you're trying to make that the subject. Okay, let me get rid of all of these just so that we have some space. Okay, so how do we make that the subject? Well, you have one term here, 1, and then you have minus 2. What we can do is take that negative 2 sine squared 10 over. Okay, so if you take that over, it becomes a positive 2 sine squared 10 degrees. And I'm just going to take this over as well. So first of all, on the right, we still have 1. Then taking this over becomes a negative cos 20 degrees. Okay, let's fill in the stuff that we already have. Cos 20 degrees, remember, is p. That is the value of p. So I'm just going to put in place of cos 20 p. So cos 20 is p. So I replace that with p. Okay, this is what we have. Now we just have to simplify, make sine 10 degrees the subject. We can go ahead and just divide both sides of the equation by 2 first. Then we have sine squared 10 degrees is equal to 1 minus p over 2. And then to solve with sine 10 degrees, you would just square root both sides because this has been squared, square root that. But remember, you always have a plus minus. Okay, but remember, you're saying sine 10 degrees. 10 degrees falls into which quadrant? The first quadrant. So it's going to be positive. So don't worry about that. It just stays positive. So this is equal to, so finally, sine of 10 degrees is equal to the square root of 1 minus p all over 2. That is our answer there. Okay, this question has popped up a couple of times. You will always notice it because it's always going to be the angle they asked for would be half of whatever your reference angle was here. Okay, so moving on to the next question. The next question, 5.3, says determine without using a calculator the value of, and we have this. Okay, so let's just focus on the amount of terms we have. See, cos A plus 55 is being multiplied by cos A plus 10. And then it's being added. So look at this, that's one term. And then we have sine A plus 55 again, and then sine A plus 10. Okay, this looks like compound angle formula, and it looks like it's singing the cos song. The cos works like this. It says cos, cos, sine, sine, and then you have A, B, A, B. Then in the middle, in this case, we have a plus. So plus. Okay, so this is what we have. Now we have to just verify that it really is literally singing that same song. As you can see, you have cos, cos, cos again, and sine, a sine. Then we also have, let's see, is it actually saying A, B, A, B? You have this first value here, A plus 55 degrees. Let me use something light. So you have this first value here, A plus 55 degrees. Okay, let's say that stands for A. If it really stands for A, it should repeat itself again here. Look at that. It is repeating itself again. Okay, then we have the A plus 10 degrees. And that A plus 10 degrees is representing the second angle. That should be the exact same thing over here. And you see that? It's the same. So it really is singing the cos song. So just like we would take this and simplify it to cos, okay, using compound angle. Remember the formulas are in the formula sheet. Cos, then you would say A, and because this is a plus here, in the cos song, this changes to a minus. I just call it a song because that cos, sine, sine. Okay, then minus B. That's what that would become. It's the exact same thing we're going to do here. So in this, we're going to actually say cos, and then what was our A? What represented our A? Our A was this first one, the first angle they gave us, which is A plus 55 degrees. So that's A plus 55 degrees. Then we have to say minus B. What represented our B here? That was the second angle, which is A plus 10 degrees. You see, A plus 10 degrees is two terms. So when you're subtracting, you need to add brackets to protect that because it's going to multiply in. So that is A plus 10 degrees. Then we close that. So I'm just going to use big brackets to close it. That's what this simplifies to. Now we just have to simplify this part. So it's equal to, we're going to have cos, and now we have A plus 55 degrees, distribute in negative A, distribute negative 10 degrees. Then this is equal to cos. You see the A, positive A and negative A would cancel, and you have 55 degrees minus 10 degrees, which is 45 degrees, and cos 45 degrees is equal to, well, if you use the calculator, it's the square root of 2 over 2. If you use the rule that you're actually supposed to use, is going to be 2 over the square root of 2. Okay, that rule, well, it's going to take a bit long to explain it now, so maybe in another video I can use that as an opportunity to explain more on trigonometry. Okay, so there we go. That's what we get. So even if you put this answer, I'm sure if you gave this answer, they'll still be fine with it. You gave this answer, it's okay. Okay, but don't take my word on that. I'm not too sure if they're strict on that. Okay, moving on to the next question, 5.3. Okay, 5.4. This is what we have. They say consider, and then they give us this. And they want us to prove the identity above. Okay, so it's not an equation, it's an identity. In identities, you just have to prove that the left-hand side is going to be equal to the right-hand side. Okay, so I like to start by stating which side I'm going to work with. We only have a negative sign x here, so can't use that side. We have to use the left-hand side. So I'll say left-hand side is equal to, and just rewrite all of this. Okay, so now we can start with this. Okay. We have to really think about this, and that's the thing about trigonometry. It's not something that you can just like do mindlessly. You have to really think about it and see how should we simplify this. So on top we have 3 terms. Okay, so first of all, the first thing you could think about is the fact that these are expressions that you eventually want to simplify and become just negative sine x. You see, negative sine x does not have a 2x in it, meaning first of all, these 2x's, they need to go, they need to change. So how do we change them? Now is where you really need to think about it. Okay, so thinking about how we're going to change this. So first of all, thinking about how we're going to change this, sine 2x can only be equal to 2 sine x cos x. So this is going to help a lot. Already knowing, okay, this one can only simplify to that. So if that changes to positive 2 sine x cos x, and then we have minus cos squared x here, okay, think about this. You have sine 2x cos x, and then you have a cos 2x. What should we change this to? Just so that it can simplify well. So look at the fact that you have a negative cos squared of x. You have a negative cos squared of x. This could have been a trinomial had this been positive, right? If you had this here positive and then eventually this maybe became something like that, then yeah, it could be a trinomial. But as you can see, this is never going to just simplify to sine squared x, right? And this is actually negative. So the best thing to do here is get rid of this. So what this needs to change to, it needs to change to something that will help to get rid of negative cos squared x. So what do we need to get rid of negative cos squared x? You need a positive cos squared x. So choose one of the double angle formulas that will include a positive cos squared x. Okay, so which double angle can we actually use that's going to get rid of that with a positive cos squared x? You could use the cos squared x. Let me actually put that in another color. You could just use instead the cos squared x minus sine squared x, and that will get rid of that problem. Okay, because you see right now we don't know how we're going to simplify that with something here. So now that can go away. Okay, so we have a denominator still over, and honestly with these trig expressions, the best way to improve in it is just to do a lot of them. So something that you can really do is work on it a lot first until you realize, okay, I really don't know the answer. Then check the solution. Okay, so then we have over, and we have sine x minus 2 cos x. I still don't know what to do with this. There's nothing I can really do with that. I can't simplify it further. Is equal to. Then on the top, this would cancel with this. And look at what we're left with now. We're left with negative sine squared of x, and then positive 2 sine x cos x. That's what we're left with. Over positive sine x, and then minus 2 cos x. Okay, so this is what we have. I need a bit of space. Okay, so this is finally equal to, on the numerator, you see how many terms do you have? You have 1 and 2. What's common in both terms, because they can't be added together, so take out a common factor. We can take out a common factor of sine x, okay? But that might not really be the right thing to do, because look at the denominator. It's probably going to cancel with whatever is left on the numerator. So let me just show you. If we just took out sine x as a common factor, it's not that you're going to be wrong, okay? Then we open a bracket. You see what will be left if you divide. So negative sine squared of x divided by sine x, okay? It's still negative. One of the signs cancel, you're left with sine x. Then over here, if we divide that, you're just going to be left with a positive 2 cos x. You see, now look at the denominator. The problem with this is it's close to being the same, but this one is negative, this one is positive. This one is positive, that one is negative. So what we should have actually taken out as a common factor is not positive sine x, but negative. Now, you would be like, how would I have known that? It's not a problem. You could have left it like this and said, okay, fine. Instead, because of this, what I'm going to do instead is on my denominator, I can take out a negative, or you could even do that on the numerator. It's just an extra step. So you can take out the negative as a common factor again. But I'm actually just going to do that on the denominator just to show you that it is possible. So we just have sine x minus sine x plus 2 cos x. And then over, look at what you have now. If you take out a negative as a common factor, you're going to see now you will have the same bracket. So negative as a common factor, it's like saying sine x divided by the negative. Remember what we're doing when we're taking out a common factor is you take out the common factor and you ask yourself, what do we multiply to this to get back to that? You see, it's like multiplying by a -1 really. So what do I multiply to -1 to get to positive sine x? You would multiply by a negative sine x. Okay, so I'm not going to leave it as a -1, just negative. Then we're doing the same thing here. What do you multiply to -1 to get to -2 cos x? You're going to multiply by a positive because positive times negative is negative. Positive 2 cos x. Okay, but the division way is just easier when you say this divided by that. The negative cancel becomes that. Okay, so now you see we have the same bracket, same thing on top, and it's one term on top, one term on the bottom. Now we can cancel. You cannot cancel across terms normally. That's common with that, so that's gone. Now we have sine x divided by a negative, and remember it is a -1 actually, an invisible one, so that is negative sine of x. And as you can see, that is your right hand side, so it is finally equal to your right hand side. Okay, moving on to the next question. So 5.4.2 says we have to determine the value of this. Okay, if you look at the numerator, you notice that this is exactly the same as the numerator here. Okay, it's only the denominator that is different. Okay, so how do we simplify this now? We're going to let's look at the fact that we have, let's actually just simplify the same way. Since the top looks like this, how did we simplify this numerator? Let's follow that up to the last place it was simplified. You see, we got this to look like this, then we got it to look like this, and then we eventually simplified it to look like that. So you can start from here if you like, or start from here. To be safe, I'm going to start from here. That numerator, I'm just going to replace this with it because I know it's going to simplify to that on top. That's why they put it as the second question, because I would have expected them to say hence determine the value of this. But that is going to be your numerator, that part. Over, and so now we can actually just simplify this. So we just have a -3 sine squared x plus 6 sine x cos x. Okay, so how do we actually do this now? It seems like we have to take our common factors on the top and the bottom. So the good thing is, you see you have negative and positive. So really just take out the same thing in both. Here, we can take out what is common. We can just take out, I'll just take out a negative. So take out a negative sine x. Open brackets. So you're saying this divided by this is just going to give you a positive sine x. And then this divided by that is going to give you a -2 cos x. Over. Then here, if we also take out a common factor, what's common? I'm going to say -3 sine x is common in both, because you see, and you have a 6, 3 is in there, or -3. Open a bracket, and so this is being divided by this. Those two numbers will cancel. Sine squared just gives you sine x. And then positive 6 divided by -3, that is going to be a -2. Then, of course, the sine and sine cancels, and you're left with cos x. Okay, so that looks nice. That looks good. It looks like it's going well. So this would cancel with this, and then we're just left with, okay, negative divided by negative is a positive. Sine cancels with sine. So what are we left with? It's not a 3, okay? On the top, you have a placeholder of 1 there. Even though negatives would cancel, you still have a placeholder of 1. So your answer is 1/3. That's your final answer. Okay, so that was for 3 marks. How much marks was this one for? 3 marks as well. Okay, so moving on to the next question. Okay, so moving on to 5.5, it says given 3 tan 4x is equal to negative cos 4x, and 5.5.1 says without using a calculator, show that sine 4x, okay, is equal to negative 0.5 is the only solution to the above equation. Okay, so we're taking this. Okay, so this is not an identity. So we have 3 tan 4x is equal to negative cos 4x. Okay, good thing they were consistent with the 4x. Whenever we see tan, you can change it to sine. So let's go ahead and change that tan to sine over cos, not sine. So we still have the 3, and we're going to change this to sine 4x over cos 4x is equal to negative 2 cos 4x. Okay, fraction here, a number here, so we can actually just take this and put it over 1 because this is an equal to sign, cross multiply. So this is going to be multiplied by that, and that's going to give us a 3 sine 4x, and then this gets multiplied by that, and that will give us a negative 2 cos squared of 4x. Okay, so this is what we have now. If you look at this expression, yeah, this has cos, this one has sine. What we can do is, since this has 3 sine, and I always see this as a hint towards this, because this has 3 sine 4x, okay, it means that it could possibly become a trinomial, because we can look at the sine 4x like just an x, or just to remove the confusion, let me call it a k. So it's like 3k, right? But here you have negative 2 cos squared of 4x. It's going to have to stay consistent. You can't have a cos squared, but then you have a sine and you're saying it's going to turn into a trinomial. We need to change this into a sine, okay? Because it's squared, we can actually change it. Remember that cos squared of theta is equal to 1 minus sine squared of theta. So we can change it like that. I'm going to say negative 2 still. Then because you see it's changing to something that has more than one term, I'm going to put brackets. So this now, this cos squared of 4x, just treat the 4x like a theta. So that's going to become 1 minus sine squared of 4x is equal to 3 sine 4x. Okay, that looks more promising to be a trinomial now. Now, if you multiply this in and distribute it, we're going to have negative 2, then a positive 2 sine squared of 4x. And then we, of course, have the is equal to 3 sine 4x. Now, I'm not taking it over because I noticed that this is already positive here. So as a trinomial in the order of its degree, this one would come first, positive 2 sine squared of 4x. Then I can take this over. So negative 3 sine 4x. And then, of course, the negative 2 is still on the left, so minus 2 equals 0. Look at how you can view this. The sine 4x, pretend the sine 4x is a k. So this is actually just 2, then sine 4x is k, but you have squared. So k squared minus 3, then you have sine 4x, which is k, and then minus 2 is equal to 0. So this is what we have. How would we factorize this? As you can see, there isn't a common factor. It's one of those ones where you kind of have to use a method of factorizing. And I have a video on my channel about factorizing trinomials and also these types as well. So look at what we have. You're going to have to factorize this, and I'm going to use something called the cross method. I look at the first term, 2k squared, and that is going to be, what is the factors of 2k squared? It's 2k times k, that gives you 2k squared. Then what times what gives you negative 2? That will be 2 times 1. But you see, put in this order, it's not going to work, because if you multiply that, remember one of this already has to be negative. If you multiply like that, that's going to be a 2k. If you multiply like that, that's also a 2k. That cannot give you 3k in the middle. So instead of putting it as 2 and 1, I'm going to change it to 1 and 2. Okay, now that it's already in this form, because we have a minus 3k in the middle, it means that the factor that becomes negative, okay, should be the bigger factor. The bigger factor here is going to be formed by saying 2k times 2. That's going to become 4. So I'm going to give the negative to that one. So negative 4k, and then k multiplied by, that can be a positive 1 plus, so k times 1 is positive k. Negative 4k plus k is equal to negative 3k. So you see, now we have the middle term. So if you are factorizing this, it really just becomes 2k plus 1 and k minus 2. Now, I know I am using this in form of k. It's kind of like saying, first of all, let sine of 4x be equal to k. Now we're going to substitute in place of k. Let's put sine 4x back in. So I only do this, or you can do this, to make it simpler, to simplify. Now to put it back as what it actually is. Therefore, if we're factorizing that, it actually becomes 2, and then the k is sine 4x. Sine 4x, then plus 1. And then open a bracket. Then we have k again, which is sine 4x minus 2 is equal to 0. And now we have this factorized, and now we just have to solve. Okay, so solving for this, we're going to say either this bracket is equal to 0 or this bracket is equal to 0, because two things are being multiplied and they give you 0. One of them would have to be equal to 0 for that to happen. So that's the logic behind that. So 2 sine 4x plus 1 is either equal to 0, or it's a case that sine 4x minus 2 is equal to 0. So let's just solve. Okay, now they didn't really say find the general solution. They just said you need to show that this is the only solution. Okay, so let's just simplify, we're not solving for x. So we're going to say take this 1 over, and this now becomes 2 sine 4x is equal to negative 1. Divide both sides by 2, and we have sine 4x is equal to negative 1 over 2, which is negative 0.5. So that is sine 4x is equal to negative 0.5. Or we have this part, sine of 4x is equal to 2. Now, this is not possible. The reason why is because look at the sine graph. The sine graph is just saying sine 4x. Its amplitude is the number in front of sine 4x. There's an invisible one here. Its amplitude is 1, meaning this sine graph would only go as high as 1 and as low as negative 1. Okay, so it will look like that. And so because of that, it's never going to go beyond 2. We will never find a solution for sine of 4x being equal to 2. 2 will be way up here. The sine graph will never reach there. So the minute you see that and there's no amplitude there, it's only like invisible. So there's an invisible 1 there. You just know that this cannot be equal to 2. Okay, and that's really the reason why. You don't have to draw that down though. Okay, so this is it, meaning sine 4x is equal to negative 0.5 only for this one. Okay, that is 5.5.1 done. Moving on to 5.5.2. Okay, this question says hence. So it has something to do with the previous question. Hence, determine the general solution of x in the equation this. Same thing as the previous. You already knew that this was the only solution. So only work with that. Only work with sine 4x is equal to negative 0.5. And that's what it's saying, hence. So we just need to find the general solution of this, because that is all of this simplified. Okay, so we have sine 4x equal to negative 0.5. First of all, when you're finding the general solution of an equation, you first find the reference angle. Okay, so I'm not saying this is 4x. I'm finding just the reference angle first. And you find the reference angle by taking sine over. When you take sine over, it becomes sine negative 1, the inverse of sine basically, right? And you find that on the calculator by saying shift sine. Now, there are two ways of working this out. In this video, I actually want to show you those two ways. Remember, if you're okay with the first way, you can skip over to the next question. There are timestamps in the description. So for the sake of everyone else, I'm just going to explain it the two ways. The first way, we're going to work with the fact that we are going to use quadrants. Okay, one way you use the quadrants, the other way you don't. When we're using the quadrants, or specifically reductions, using the reductions, this is what you're going to do. You're going to say, okay, we're saying shift sine and we have a negative 0.5, but we just want the reference angle. We don't care that the angle is negative. Okay, so we're not going to say of negative 0.5, we're going to say of 0.5 or half. Still the same thing, right? And when we find that reference angle, what are we going to get? Shift sign of a half is 30 degrees. So like you can see 30 degrees, that's what we get. And this is now how you're going to solve. First of all, you're going to consider the fact that sine of 4x was negative, right? So sine of whatever you had was a negative value. And ask yourself now, in which quadrants is sine negative? Sine is negative in the third and the fourth quadrant. So that's what we're going to say. It's in the third and the fourth quadrant. So we're going to use these reductions. In here, we have 180 degrees plus theta. Here we have 360 degrees minus theta. We're going to use those reductions on this that we have. Since we have sine 4x now, we're just solving. Now we're finally solving for 4x. Here, we just call this a reference angle. But now we're finally going to solve for 4x. So I'm saying 4x is now equal to. Then you're going to use the reductions. The first one you have is 180 degrees plus theta. So we're saying 180 degrees plus theta being our reference angle. And our reference angle is 30 degrees. So plus 30 degrees. Then this is a general solution. We're not solving for the exact values of x. So because it's a general solution, you need to say plus k of 360 degrees in this case, because we are speaking about the function sine. The sine graph repeats itself every 360 degrees. So you say plus k 360. Now other schools may use N or T or P or any letter. You can. That's why at the end you need to tell them what k is. That's why we say k is an element of integers. Then we say or. So that's the first part we have, right? First, that one. Then we have to use this 360 quadrant. We are solving for the actual angle we have. The angle we have is 4x. We're saying 4x again is equal to 360 degrees minus, and now theta, our reference angle, is 30 degrees. Again, it's still sine. So we're going to say plus k 360. In class, you may call this 360k, still the same thing. I just like to say k in front so I don't forget it, because I notice when we write fast, I end up forgetting the k there, and that's wrong. So that's why I put the k in front. Then you need to say, now you're telling them what k is, because everybody has different letters for this. They may have. K is an element of integers. It can only be integer values. Okay, now we can finally solve for these. So what is 180 plus 30 degrees? We're saying 4x is equal to 210 degrees plus k 360 degrees. And then finally solve. If you want to solve for x, you're going to have to divide both sides by 4, but everything gets divided by 4. So look at what happens. We have x is finally equal to 210 divided by 4. So 210 divided by 4, that gives you 52.5 degrees. 52.5 degrees. Now, plus k of what? What is 360 divided by 4? 360 cut into 4 quadrants is 90 degrees. So, plus k of 90 degrees. You see, this solution is now repeating itself every 90 degrees and not 360 degrees anymore. Okay, then we can have here over here, we're just going to say divide both sides again by 4. Well, let's just solve for that first. So we have first 4x is equal to 360 minus 30 is 330 degrees, and plus k 360 degrees. Don't have to rewrite that again. It's written once, it's fine. Divided both sides by 4, and then we're going to have x is finally equal to, so let me just put all here, 330 divided by 4, and that gives you 82.5 degrees plus this divided by 4 is k of 90 degrees. There we go. And those are your general solutions. So remember I said I'm going to do 2 methods. If you are okay with this method, you can go on and skip. Then I'll do a second method and show you that the answer is still correct. Okay, the second method is not using reductions. Well, technically you are using reductions, but you're only using the reductions that belong to the specific function you're working with. Okay, so this is how method 2 looks. This same equation, sine 4x equals negative 0.5. I'm just going to call it sine 4x equals negative a half. In this method, you only have to remember the reduction for sine. If you're working with sine, you're only going to think about it like this. Sine, okay, whenever you have sine and you're solving for sine, you're only going to ever use these two reductions. You're going to use theta and 180 degrees minus theta. Finish. You don't use anything else. You don't have to think about stuff too much. So the second method, this is what we're going to do. We don't even bother that this is negative. We're simply going to take sine over. To find that reference angle, we're literally just saying this is equal to, and we're going to say shift sine of negative 1 over 2. So shift sine negative 1 over 2, what does that give you? It's going to give you a negative sine theta. So shift sine negative 1 over 2, negative 30 I mean. Negative 30. So reference angle is finally equal to negative 30 degrees, right? And we're going to use it like that. So look at what we're going to do. You will always use the functions, or really the quadrants, the formulas belonging to this function. So we're only using those two because that's where sine is positive. Okay, so now to finally solve for 4x, or to solve for x, we're going to say 4x is equal to, the first quadrant we have is theta, meaning whatever your reference angle is, use that. So theta is negative 30 degrees. And I'm going to just say plus k of 360 degrees, because this solution will repeat itself every 360 degrees. Then you can say, or 4x is equal to, and we're going to use that, 180 degrees minus, and then we have negative 30. So negative 30 degrees plus k of 360 degrees, where k is an element of integers. Then, now that we're at this point, now there's two routes you can take here. You can either identify that you have a negative angle, and if you want your answer to end up looking like this one immediately, what you can do is, okay, I have a negative angle, let me add 360 degrees to the negative angle. So you could have just done that, add 360 degrees from here. Now that will give you 4x is equal to, and then that's going to be 330 degrees plus k, 360 degrees, and I hope you see what's going on again. Okay. Then here you see you have 4x is equal to 180 degrees, and then you can just multiply in like that. So that's going to be 180 degrees plus 30 degrees, which of course gives us a 210 degrees again, plus k, 360 degrees. And as you can see, we're just doing the exact same thing. So there are two methods that you can take. Okay, so you can do that. Another thing that you can do, I'm just trying to show you this just so that if you actually did one method, don't think now your answer is wrong. Your answer may not even be wrong. There's also another way where you don't add 360 here, but you leave this as it is. First of all, we're just going to divide both sides by the 4, right? And look at what we get. X is equal to negative 30 divided by 4. 30 split into 4 parts. 7.5. 7.5 degrees, right? Plus k of 90 degrees. This is your final solution for x. Sorry, it should be negative because it's negative, okay? If this was your solution, it's not wrong. For this one, I'm not even going to bother too much. Even if this, you divide both sides by 4, you end up with the exact same answer as you had over here. With this one, what I mean by your answer is not wrong is the problem with this, not problem, it's not even a problem. The thing about this one is this is negative. This angle is negative. Now, this is slightly different. Because the angle is negative in this situation, I know people will think, oh, just add 360. No, you don't add 360 for this particular solution. This particular solution will repeat itself every 90 degrees. So you don't add 360, you add 90. So look at this. If you said x is equal to negative 7.5 degrees plus 90 degrees, right? Just to put it in a positive angle. Right now it's just negative. You see, so the difference between this one, okay, this solving for x, is that this answer is repeating itself every 90 degrees. But when we have 4x here, the reason I could add 360 degrees is because this solution as 4x is going to repeat itself every 360 degrees. Okay, so if you had to say that negative 7.5 plus 90 degrees, look at what it gives you. You see that? That looks familiar. 82.5 degrees plus k of 90 degrees. That is the exact same thing we get here. You see what I mean by it's not wrong, it's just negative. And that's not a good or bad thing, it's just how you measure it. Okay, so that is it for this question. And we finally move on to question 6. Okay, so we're now on question 6. And question 6 says, in the diagram below, the graph of f of x is equal to tan of x minus 45 degrees is drawn for where x is an element of negative 90 degrees to 180 degrees. So this is a tan graph that we have, but notice what is going on here. Always notice the things that happen here. First of all, this graph has minus 45 degrees. Remember, when you are affecting the x, if you have a minus, it means that the graph is actually moving to the right. If you have a plus, then it's moving to the left. Okay, it's the other way around for the left and right movements, the things that affect x. So as you can see, this has moved 45 degrees to the right. Okay, that's how the graph has moved. So you can already just think about it like the original tan graph, everything that it has here, like here, say the number that it has at 90 degrees, it's supposed to have that 45 degrees before this, because the graph itself moved to the right from where it originally was. Okay, so let's keep that in mind as we move on. The first question they asked, 6.1, is write down the period of f. So the period of f, now when you think about the period of a graph, is how long does this graph take to complete a cycle? In the sine graph, very simple. You have a sine graph, look at what it does. It does this, up, down, hits there, and done. That is one cycle. And a sine graph takes 360 degrees to finish a cycle. Just a normal sine graph, a graph that has not been altered in any way. So the tan graph, on the other hand, that's why we say plus k of 360 degrees in general solution. The tan graph, you would remember that we say plus k of 180 degrees, because the tan graph actually takes 180 degrees to complete the cycle. Now you have to also check, has the cycle been altered? Has the period been altered? You just have tan and you have an x on its own, right? Then minus 45 degrees. When you know the period is altered is when you have something in front of the x. So if you had like tan 2x, then the period has been altered. Okay, so it has not been altered in any way. So it's behaving like a normal tan graph, it's just shifted to the right, meaning its period would still be 180 degrees. Okay, I will be doing this from time to time. I don't want this to just be a memo where I'm just going to tell you the answers. I really want you to understand why things are happening in it. Okay, moving on to the next question. Okay, so question 6.2, this is what they ask us to do. They say draw the graph of g of x is equal to negative cos 2x for the interval x is an element of negative 90 degrees to 180 degrees on the grid given in the answer book. Show all intercepts with the axes as well as the minimum and maximum points of the graph. Okay, so they are telling us to show intercepts and minimum and maximum points. So we just also remember to do that. Okay, so the graph we have is g of x is equal to negative cos of 2x. To be able to draw this graph, okay, within this interval, and here's the graph paper already, to be able to draw this graph, you need to understand how the original cos graph works. So the original cos graph is y is equal to cos of x, that graph. So from this, we're going to find out what is actually happening to this new graph. G of x is equal to negative cos of 2x. Okay, so let me draw a simple cos graph. Let's say we have this is our y-axis, and so let me just actually make it 4 lines down. So we're going to go from here, and then here's our x-axis. So this is 1, this is -1, and let's just go till 360 degrees. So in the middle, we will have 180 degrees. So let's say 180 degrees here, and then 90 degrees and 270 degrees. Okay, so the normal cos graph, you can basically find this even by using your calculator. If you say cos of x, okay, so the first x value that we have, and the first x value that we have would be here, 0 degrees. So let's find out what cos of 0 is. You see, cos of 0 gives you 1. So it means that at 0 degrees, your y value is 1. And if you tried cos of 90 is going to give you 0. Okay, so you can try that on your calculator. But then cos of 180 degrees normally would give you -1. And then cos of 270 would be 0, and cos of 360 would be 1. So it forms a cos graph that looks like this. Okay, so we join it like that, and then it curves up and there. So this is one cos graph, and this, we will regard this as one cycle. The cos graph and the sine graph, they take 360 degrees to complete a cycle. That's what they do. Okay, so this is one cycle. So it means that after 360 degrees, right? So if we go from 360 degrees to 720 degrees, okay, that is 360 degrees later. You will have the exact same pattern. Again, you'd have it go like that, round and back up like that. And this will continue till positive infinity and even negative infinity. Okay, so now that we understand how this graph looks, we need to understand, so from this graph to this, what actually happened? Well, first of all, let's deal with the fact that we have a 2x over here. So you see 2x. So what is the 2x doing? Well, let's think about what the period of the graph is. You see, in this first question, they asked us for the period of f, okay? And f is a tan graph. The tan graph normally completes a cycle, okay? Just like this one. A cycle just means how long does it take to repeat itself again. So a tan graph completes a cycle in 180 degrees, but a cos and a sine graph completes a cycle in 360 degrees. So the original cos graph has a period of 360 degrees. Okay, so if it has a period of 360 degrees, what kind of period does this one have? What is the period of this one? Well, you have a 2x here. When you put a 2x here, to find the period, the new period, you're going to take the old period of the original graph. It's a cos graph, and you will divide that by whatever number is here, the coefficient of x, which is 2. This is going to have a period of 180 degrees. So what does this mean? It means that this graph that we had like this is going to now complete one cycle. It's going to have this exact pattern, but it will not complete a cycle in 360 degrees anymore. It will complete a cycle in 180 degrees. So it's going to look like this. If I take this graph and I copy it, I just want to show you what it's going to look like. Since it's taking 180 degrees to complete a cycle, right? This is what's going to happen. This graph that looked like this before, it's going to complete a cycle in 180 degrees, and it's going to look like that instead. You see? So now it's completing a cycle faster. So that's what's happening with that 2x part. Okay, the graph is becoming more narrow. Then now let's talk about that negative. Okay, what is this negative doing? Remember, you have a g of x is equal to negative cos 2x, right? G of x stands for the y values of the graph. It means whatever cos of 2x is, you're going to take that and you're going to multiply that by a negative. Okay, so along with the period, I actually forgot to say this. You're also supposed to now find out. So I need another graph. I want to just show you what happens to all these angles here. You see, the same way the period, right, gets divided by 2 by the coefficient of x. All the angles that you have here, we're also going to take them and divide each of them by 2. So as you can see, this graph, this new one, is going to complete the cycle in 180 degrees. So I'm going to just draw it till 180 degrees. So if we have 180 degrees here, then look at what is going to happen. We're taking this graph and we're looking at the fact that, so before we had at 0 degrees, this is 1, this is -1. At 0 degrees, okay, we had a y value of 1. But now all the angles, just like the period, they're going to get divided by 2. But you see, if you say 0 degrees divided by 2, it still gives you 0 degrees. So here, we will still, if you just say y is equal to cos of 2x, you're still going to have a y value of 1, okay, at 0 degrees and 1. Okay, and let's just focus on this one for now. So we will translate it after. We're going to find out what this negative is going to do to it. So here, we still have a y value of 1. Then, what are we going to have next? You see here, the next point that we have, let me actually move this graph away, the blue graph, okay? So I will put the blue graph where it's supposed to be. Here, we have 90 degrees. There's 90 degrees as well. That angle is also going to get divided by 2, just like the period. All the angles now get divided by 2. And that's going to give you 45 degrees. So now, what happened at 90 degrees, where we had 90 degrees and 0, we're going to now have at 45 degrees. So now we will have 45 degrees and a y value of 0. Then the next angle, we have 180 degrees. Again, that angle is going to get divided by 2. And we're going to get 90 degrees. So what happened at 180 degrees in the original graph, where we had 180 and negative 1, we're now going to have at 90 degrees. So that's going to be 90 degrees and negative 1 as your y value. And then lastly, we have 270. Okay, so second last, 270 degrees, you're going to take that and you're going to divide it by 2, which gives you 135 degrees. And so we're going to take 135 degrees. Whatever happened at 270 degrees now happens at 135 degrees for this graph. So 135 degrees and 0. So that's your y value, 0. Then lastly, as you can see, it took 360 degrees here to complete a cycle. It's completing it in 180 degrees. What happened at 360 degrees, you say 360 divided by 2, will now happen at 180 degrees. So that's 180 degrees and 1. Okay, so this cos graph ends up looking like this. Okay, like that. It's squeezed. So that's this part, okay? This y is equal to cos of 2x. Now, all of this is not supposed to be happening as you calculating. I mean, you can do little sketches, but you probably do it with a pencil, then you can erase it, just so that you can draw the g of x, okay? But this really happens in your head most of the time. You understand the old cos graph and you start to translate it into the new one. So remember, the new one is actually this g of x, but I want to put that actually on this paper. So let's see what happens. Now we know this is what this graph over here looks like. But what will g of x look like? G of x says negative cos 2x. So remember that g of x stands for the y values, meaning when we say y is equal to cos of 2x, for example, when we say y is equal to cos of 2 bracket 0 degrees, okay, like this one here, we get a y value of 1, and you can even try that on your calculator. But because this says g of x is equal to negative cos of 2x, that answer that you get, that 1, is now going to be multiplied by a negative, okay, or negative 1 really, because g of x has a negative in front of it. So I'm translating the g of x graph now. So this is what's going to happen. All the y values that you had for your graphs, they're going to get multiplied by negative 1. So this is what our g of x is now going to look like. At 0 and 1, we're now going to have 0 degrees and negative 1. So that's what's going to be here, 0 degrees and negative 1. Then at 45 degrees, now we're going to have 45 degrees and 0. If you take 0, the y value of 0, and you multiply by negative 1, it still stays 0. So you still have 45 degrees and 0. Then at 90 degrees, you see we have a y value of negative 1. Instead, we'll have 90 degrees and the negative 1 gets multiplied by negative 1, which gives you a 1. So 90 degrees and 1. 90 and 1. Then at 135 degrees, we're going to say 135. The y value is 0. 0 times negative 1 is still 0. 135 and 0. Lastly, we have 180 degrees and 1. That gets multiplied. It has a negative 1 now, so 180 and negative 1. So that's how that looks. But then, let's also understand now how will this part look, because they said we have to draw the graph for this interval, negative 90 to 180. So the thing about the cos graph is, so if I draw this is going to look like this now. and then it curves down like that and like that. So that's what that looks like. So remember how I said that the cos graph is just going to repeat itself every 360 degrees, the original one, right? But now, of course, because this graph, its period has been changed, okay? We have 2x now. It now completes itself every 180 degrees. So this is what this one's going to look like. If we have the same graph, and I just want to show you what it's going to look like behind this. So if we drew intervals for negative numbers as well, like behind here. So if we drew intervals like this over here, you see the same graph, this exact graph. It will repeat itself again 180 degrees before this, because of course this graph has been altered, the period is changed. So look at this now. This graph is now going to be here again like that. You see? So the cycle is now repeating itself every 180 degrees. And so because it repeats itself, it means that whatever happened here is going to happen there again. So when we're counting this, we have 0 degrees. Then at this point again, it's symmetrical, you see. It's symmetrical here. So it's symmetrical where it started from. So from here, when you go backwards, it's going to do the exact same thing. Here, instead, you're going to have negative 45 degrees and 0. Okay, then here you had 90 degrees and negative 1. The next value, the next point, that's going to have a y value of negative 1 is now going to happen at negative 90 degrees. And then you had 135 degrees and 0. The next point that will have a y value of 0 again here would be negative 135 degrees. And lastly, of course, 180 degrees and 1. The next point is going to have negative 180 degrees and 1. You see what I mean by it is symmetrical. So that's how it looks. Okay, so from this one, now we know what this one is going to look like. Okay, so we have 0 degrees. Then at negative 45 degrees again, you're going to have, since this is 45 and 0, you're going to have another point here, 0. Okay, at 90 degrees, you had 1. Then it's going to happen again at negative 90 degrees. Negative 90 degrees and 1. So that's what the graph is going to look like. Okay, there. So something like that. Let me just make the line more. Okay, I'm just going to leave it like that. So the name of the graph is G. So just put G. But also just remember that they said that you also have to show or intercept minimum and maximum points of the graph. So I'm also going to just do that. For the intercepts, I'm not going to write the points down, because even on a parabola and stuff, you don't have to write those points if it's an intercept. If it's intersecting here at negative 2, you don't have to write negative 2 and 0. You leave it like that. Okay. So for the intercept, I will just leave it. So that is an intercept, 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 and here's a y-intercept. Okay, but this y-intercept, I'm going to write the point, because this, they said you need to indicate, show all the minimum and maximum points. I don't know if this is necessary, but since they said show all, so I'm just going to show it still. The coordinate here is 0 degrees and negative 1. So I'm just writing it 0 and negative 1 degrees. Okay. And then the another point that is a minimum or maximum would be here. We have a maximum. This graph will not go beyond this. That is the highest point. Then it starts to decrease again. So here we're going to have negative 90 degrees and 1. And of course here we have 90 degrees and 1. And lastly, we have this point, 180 degrees and negative 1. Okay, so that's how I'm going to leave that graph. And that is 6.2. Okay, moving on to the next question. Okay, moving on to the next question. 6.3 says we need to write down the range of G. Okay, so if you think about how this graph goes, the range is all the possible y values the graph will have. So if we're looking at the y-axis, look at all the y values this graph is going to have. G, right? You see it has a y value here and here and here, even below here. But look where it will never go past. It will never go past 1. This is the highest y value it will have. You see, if you draw a straight line, you'll see it will never pass 1. And it will also never pass negative 1. That is the lowest y value this graph will have. So the range can be written as y is an element of from negative 1 all the way to 1. Now the kind of brackets you put here is important. If you put round brackets, you use round brackets for things like infinity and when the point is not included. What I mean by when the point is not included is if it's not an actual, if this y value is not an actual y value on this graph. In this case, this is a y value on the graph. You see, there is a literal point that has a y value of 1 and a literal point that also has a y value of -1. So because these points are included, I don't have to use round brackets, but rather square brackets. So that's how you'd write that. Other ways of writing this, you could have also just said y is greater than or equal to. Okay, so equal to because this is also a literal point, a literal y value on that graph. -1, but less than or equal to 1. So that's another way you could have also written that. Okay, moving on to the next question. The next question, 6.4, says the graph of G is shifted 45 degrees to the left to form the graph of H. Okay, determine, so 45 degrees to the left to form H. Determine the equation of H in its simplest form. Okay, so there is a new graph. The name of the graph is h of x. It is formed by taking g of x and shifting it 45 degrees to the left. Remember, when we're moving to the left, you're not going to minus, because when you're moving to the left or the right, you are affecting the x value. When we're moving up or down, you're affecting the y values of the graph. So when it's moving to the left, you say plus. When it's moving to the right, you say minus. It's the other way around, remember, for the x's. But it doesn't work like that for up and down. So here, I'm saying the new graph of G is formed by taking all the x values of that graph. And then, because it's moving to the left, we're going to say plus 45 degrees. Now, all we have to do is apply this to the equation of G. So I'm saying h of x is equal to, let's find G. What you're going to do is, you see this is G of x plus 45 degrees. It was supposed to be G of x, meaning wherever you see x, you will replace it with x plus 45 degrees. So the graph of G was negative cos 2x. So instead, we're going to have negative cos 2 in place of x, x plus 45 degrees. And we have to now simplify this. Now, it's weird that I put it like this. Cos has a bracket in front of it because it has an angle. So I'll just use big brackets here. Okay, so this is what we have. And we have to simplify this, put it in its simplest form. So h of x is equal to, we have negative cos. And so here, we can distribute the 2 into these angles. And so we're going to have, in a bracket, 2x. 2 times 45 is positive 90 degrees. And then this is equal to, okay, so how do we simplify this? We have a 90 degrees, which immediately you see 90 degrees, you should think of co-functions. So let's think about co-functions. Let me put it in the right order. Notice that co-functions usually look like either 90 minus an angle, theta, or 90 plus an angle, okay? So instead, I'm going to rewrite it with 90 degrees first. So negative cos, then I say 90 degrees plus 2x. Okay, now we can actually change this nicely. So this is actually the same thing as, don't worry about the negative, we will apply that. But I'm focusing on the cos, this part, cos 90 plus 2x. This is the same thing as cos 90 degrees plus theta. What does this one become? Remember, in your cofunctions diagram, it's the only one that becomes negative. So it becomes negative, and because it's a cofunction, it changes to sine theta. Okay, same thing we're going to do here. So we still have this negative on the outside, then this becomes negative. So I'm going to put brackets, negative sine of whatever angle we have. We have 2x. That's what we're using, not theta. We're using 2x here. So 2x. Then lastly, h of x is equal to, we will take that and multiply it in, distribute it, and we have a positive sine of 2x, and that's h of x. Okay, so that's how we work through that one. Okay, moving on to the next question. So 6.5, we have used the graphs to determine the values of x in the interval where x is an element of negative 90 degrees to 90 degrees. This is important to take note of. It's not the same as all the other ones they have been given us like that, you see. So that stops at 90 degrees. Okay, and for which First, they're asking us about f of x. F of x is the original graph we have. F of x needs to be greater than 1. So we need to find out where is f of x greater than 1. So looking at our graph, remember the tan graph, that is our graph of f. H was this new one that we just created. Okay, so this is our graph and we need to find out where is it greater than 1. All you have to do here is, okay, I was just trying to get those out of the way. So this is what we have, right? We're looking at the graph of tan because that's f, right? And we just need to see the places where it is greater than 1. So mark a line, a horizontal line, because greater than 1 refers to the y values. So where is it greater than 1? Here's 1. These are all the numbers greater than 1. So here you can mark a horizontal line so that you can find out where is this line above 1. Okay, so where is this graph above 1? So look at it. It's over here. That's greater than 1 over there. It's also greater than 1 over here, but this is where now you need to hold on and consider whether we can take this or not, because you always have to look back at the instruction. You see, they said where x is an element of negative 90 to 90. So let's already mark a barrier line so we know we don't take past that. Okay, so is it only for this question? No, it's for both questions because they put it here. So we're going to put a line here. I'm not going to take anything past that. So I'm not even going to consider that. I can't take that anymore. They want only greater than 1 between negative 90 to 90 degrees done. Okay. They didn't say greater or equal to 1, just greater than 1. So it will be everything above here. So here, okay, that point over there, that point, keep going. So let's see, what are the x values that belong to this point? Look at that. If you line it down to the x-axis, it's this point over here. You would have to compare it to negative 90 degrees because at negative 90 degrees, the y value of this tan graph is 1. Okay, so these numbers, look at the numbers here. They are numbers that are what than negative 90 degrees. They are moving towards the side, so greater than negative 90 degrees. Okay, and it's the tan graph. Remember, the tan graph has asymptotes. Look at the first asymptote it has at negative 45 degrees. So it's here greater than negative 90 degrees, but it will not go beyond this because there's an asymptote here. And then, of course, after the asymptote, you see, look at the graph. They all have values less than 1. So the answer for that would just be where x needs to be greater than negative 90 degrees, but less than negative 45 degrees. Okay, that would be your solution for that. Okay, so that is that. Then we move on to the next question, the last question for question 6. Then 6.5.2, we have to determine the values of x for which 2 cos of 2x minus 1 is greater than 0 for, of course, those same intervals. Okay, for these intervals. So with this question, you see, at this point, this is the last question. They will not introduce a brand new graph. As you can see, you see the cos 2x. It's probably related to that graph of g of x. And just remember, g of x is equal to, let me actually put it in blue so we'll focus on it more, is equal to negative cos of 2x. So let's take this inequality and let's try to get that part to become negative cos of 2x. So if we have 2 cos 2x minus 1 is greater than 0, and then let's think about what we should take over. Notice that this one is negative cos 2x. Okay, so we want whatever has cos 2x to stay negative. So how about we just take that over to this side? So this is now negative 1 is greater than negative cos of 2x. Then, of course, we have to solve for this part. But remember, we want negative cos of 2x to stay. So I'm going to try and leave this here, meaning I just need to get rid of the 2. So let's divide both sides of the equation by 2. And so here you have negative a half. Remember, we divided by positive, not negative, so that doesn't change. And then we have the sign, and we have now still the 2's here cancel. You're left with just the negative cos of 2x. Okay, now we know we have g of x over here. Let me just rewrite this in a way that it's just going to make more sense where this is in front. So I'm just going to put negative cos 2x over here. The negative a half is over here. Now you just have to follow the sign of the inequality. You see, the open side of the inequality, the mouth is facing the negative half. So here, write it facing the negative half. So this is basically what we have. And so they basically want us to find out, since this is the graph of g of x, where is g of x going to be less than negative a half? Okay, so where is it going to be less than negative a half? Let's look at the graph. So if this is the graph of g of x, but remember, we have to find out where it's going to be less than negative a half between negative 90 degrees all the way to 90 degrees. Okay, so I'm going to draw a line here again just to separate that. I'm not going to go past this. So if this is 1, 0, negative a half would be somewhere here. So if we have negative 1 over 2, right? I want to find out where the graph will be less than this. So I'm just going to draw a horizontal line representing that point, negative a half. And I just want to find out where does the graph have y values that are less than negative a half. So as you can see from that, that would happen in all these places over here, all the way here. Let me just use something darker. So it's all these points in between here. But where does it start? In other words, where is the cos graph itself? Okay, where does it have a y value of negative a half? You see that it has a y value of negative a half here because this is the y value. We need to find out what exactly that x value is. And where else does this happen throughout here? So here, if you look throughout, it also happens here again. Okay, here the graph has a y value of negative a half. We also have to find out what exactly that x value is. And obviously, if you do go on, you also see that the graph would have also intersected here. But the reason I'm not going to even bother about that point is because we cannot go past this line. We must go from negative 90 to 90 degrees only. Okay, so how do we find out now what these two values are? So you can see it's between 0 and 45 degrees and then 0 and negative 45 degrees. Remember that the cos graph is symmetrical. First of all, we will be able to find this one over here. Okay, the reason we'll be able to find this one over here is because we have the equation of the graph of cos, negative cos of 2x. So this is how we will find this one over here. Okay, it's the one that is between 0 degrees all the way to 90 degrees. So I'll do that over on this side. So this is how we can find that. Since we already know the equation of the graph, right? And we need to find out where the graph is equal to negative a half. I'm just going to say, where is negative cos of 2x equal to negative a half? And all I'm going to do here is solve for x. And I'll show you what it means when you solve for x. Okay, so I'm going to solve for x just to find that first point. So it's not going to be as general solutions. We're just solving for x, that's all. So if you solve for x here, first of all, we need to get rid of that negative. Divide both sides by negative 1. Cos of 2x is now equal to positive a half. And then to solve for x, you're going to have to take cos over. And so you have 2x is equal to shift cos of a half. And this is really a grade 10 kind of equation that you would have seen. In grade 10, you guys got equations like this. Okay, so 2x is equal to, if you say shift cos of negative a half, so shift cos negative 1 over 2, it gives you 120 degrees. Okay, so oh, why did I say negative 1 over 2? It's 1 over 2. So 1 over 2, sorry. It gives you 60 degrees. Okay, that didn't even seem right. So it gives you 60 degrees. Then we have to solve for x, of course. Divide both sides by 2. And look at where we get. X is equal to 30 degrees. I want to show you what this means in the graph. So x is equal to 30 degrees. This is where it happens, here. Okay, that's where we get that 30 degrees. So since we know this is 30 degrees, remember what I said about the cos graph. It's going to repeat itself basically. Remember, this is just negative cos of 2x. It's not negative cos of 2x minus 45 degrees. It's not being shifted to the left or to the right. The period of the graph is just being changed. And of course, the y values are being multiplied by negative 1. So if this graph is doing this over here, right, all the way to 180 degrees, it completes one cycle. It's going to do the exact same thing after 0 degrees, or really just before 0 degrees. So exactly the same thing. So think about it like this. If here at 45 degrees, we have a y value of 0, then at negative 45 degrees, you also have a y value of 0. Then if here at 30 degrees, we have a y value of negative a half, then it means that negative a half as a y value will appear again at negative 30 degrees. Okay, so now we know these two numbers, right? And we're just basically trying to find out where is the graph of this, right, going to be less than negative a half. That was the inequality. So we found out that this is this region over here. Let's map it to the x-axis. So you see it's a point here, here. These are all the places where the graph of g is smaller than negative a half. So what are these x values? You see they lie between negative 30 and 30, all of these values. So it's where x is greater than negative 30 degrees, but less than 30 degrees. And that will be your solution for that. So there we go. X is greater than negative 30 degrees, but less than 30 degrees. Okay, moving on to the next question, question 7. Okay, so we're on question 7, and question 7 says, in the diagram, A, B, and C are points in the same horizontal plane. Okay, so there it's on the same horizontal plane. So it's kind of like the ground of this. Then we have D is a point directly above C. That is DC is perpendicular to AC and DC is perpendicular to BC. So there you have perpendicular lines. Then they say it is given that ACB is 100 degrees. So there's 100 degrees. CAD is 30 degrees. AD is 20 units and BC is 8 units. Okay. They want us to first calculate the length of AC. Okay, so when you see them asking you actually for numbers, it feels better than them asking you for you to just determine, let's say, AC in terms of x. It's better than that, honestly. So we have the length of AC. AC is this part over here. How do we find the length of AC? Just look at what is AC part of, what triangle is it part of? Well, it's part of this big triangle, but unfortunately here all we have is 100 degrees and 8. That's not enough to actually find this length. So we can focus on this triangle instead. So this triangle is right angled, which is good, meaning you can possibly use Pythagoras, but as you can see, Pythagoras is not possible here. You only have one length. You don't even have that. Neither do you even have AC. Second thing to use when you see right angles would be trig functions. Okay, so if we're using trig functions, let's first of all understand which sides we're going to use. Definitely we're going to be using AC because it's what they asked us for. You have to relate AC to 30 degrees. Where is AC in respect to 30 degrees? It is next to 30 degrees. So this is your adjacent side. Then in this same triangle, you need to take something that you already have, like the length of something that is already available, which would be AD. AD is 20 units. We know that already. And what is AD in relation to 30 degrees? It is the hypotenuse. Okay. So you see the function we have here. We have adjacent and hypotenuse. Where does that appear? So if you remember that word SOHCAHTOA, so about cos, sine, and tan, you see that adjacent and hypotenuse would appear in cos. So you're going to use cos for this. So we're going to say cos of what? Cos of the angle that we're referring to, that we related these sides to. That was 30 degrees. Cos 30 degrees is equal to the adjacent side, which is AC, over the hypotenuse, which is 20 units. And all you have to do now is just solve for AC. So get AC on its own. To get AC on its own, we need to get rid of the 20. We can multiply both sides by 20. And so this will give us 20 cos of 30 degrees being equal to AC. So you can put that onto the calculator and see what you get. And that gives us 10 square root of 3 units. So that is the length of AC. Moving on to the next question. So I'm going to actually put that down just because we need to really always put down what we have. So that is 10 square root 3. Then next question, 7.1.2 says we need to determine or calculate the length of AB. AB, now that we have AC. So AB, A all the way to B, opposite it, we have 100. If we had one of these angles like this, we could have easily just used the sine formula, but we do not have that, so we can't use that. Okay, so let's look at what else we can use. Since AB is part of this bottom triangle, you see that we have BC, we have AC, we have the middle angle. They want us to find AB. So this is clearly the cos rule that you have to use. So remember, the cos rule basically says you always have to start with the length. We'll say this length, AB squared, is equal to, then you take the other length, BC squared, plus that one, AC squared, minus 2 multiplied by BC multiplied by AC, and then you say cos of that angle, okay? And the angle is 100 degrees. And in this case, this formula is fine because we want AB. I apologize for the noise outside. I'm not sure if the mic is picking it up. Okay, so looking at this, we're going to just say AB is finally equal to, AB squared is equal to, what is BC? BC is 8, AC is 10 square root 3, so 8 all squared plus 10, well, you don't have to all say all squared, it's just 8 squared plus 10 root 3 squared, and then minus 2 multiplied by 8 multiplied by 10 square root 3 cos of 100 degrees. Okay, so you can put this all onto the calculator and let's see what we get. Or you can already from here square root both sides. So square root just to find AB. And so AB is equal to all of this. Okay, just make sure you punch everything in properly. And when you put that 10 square root 3, make sure you just come out and then square it, okay, with the side. And so you see AB is equal to 20.2 decimals. It looks like it could be 1 decimal, but okay, 20.30 units. Then moving on to 7.2, it says, if it is further given that ABD, angle ABD, is 73.4 degrees, calculate the size of ADB. Okay. Okay, so with all these questions, always make sure you fill in what you have. So AB is now 20.30 units. I'm going to put that in there so I know that is now 20.30. Okay, so let's see what they're saying. They said if angle ABD is 73.4 degrees, ABD is ABD. You see, that is actually this whole angle. Okay, so this is a 3D object. This is like the face of the object. We're looking at that angle. Okay, so that angle is the 73.4 degrees. If that is the case, they want us to find ADB. So what is going to be ADB? This angle. Okay, so let's look at what we have. We unfortunately don't have this entire angle, this face, okay, this part here, the DAB. So we can't use interior angles of a triangle. But let's look at this. Since they asked us to find this angle, what side is opposite it? It's this side that we found, 20.3 units. And the angle that we have, it should also have an available side opposite it. So here it has an available side, 20 units. So we can use the sine rule for this. Okay, because we're looking for an angle, I will start with the angle first. So I'm going to start by saying sine of that angle. Actually, we would have just called this angle D, but okay, let's just call it ADB over, and then over the side that you have. The side you have is 20.30. So 20.30 units is equal to, again, we're going to have to say sine of the second angle we have, which is this over here, the 73.4 degrees, over the side opposite it, which is 20 units. Okay, this is our equation. So we just have to solve for this equation as it is. Remember, we're just trying to find the value of angle ADB. So instead of cross multiplying, something we can do is try and make sine of ADB the subject by getting rid of 20.30, and you do that by multiplying both sides by 20.30. Okay, 20.30. Then we're going to have sine of ADB is equal to, and we have all of this basically. So when all of this is being multiplied, this is sine of an angle. This can go in front of it because it's a number that you're multiplying to this function. So it's now 20.30 sine of 73.4 degrees all over 20. Then to solve for ADB, so to get that angle ADB, you're just going to take sine over. So now we have ADB, that angle is equal to, and when sine comes over, it becomes the inverse, which is shift sine, and then we just say 20.30 sine 73.4 degrees all over, close that bracket. So that's going to be very important in the calculator, over 20. Okay, so let's see what we get here. Okay, and so ADB, angle ADB is equal to 76.58 degrees rounded off to 2 decimal places. And that is it for question 7. And finally, we move on to question 8, which is Euclidean geometry. Okay, so now we are on question 8, almost done. So question 8 says 8.1, in the diagram, O is the center of the circle. We have K, T, and L are points on the circle, okay? And then they tell us that KT, TL, KL, OK, and OT are drawn. So nothing special about them. They didn't say anything about them being tangents. That's what I'm looking for. Okay, but remember, these are radii. So, okay. And then they tell us that OT intersects KL at M. ST is a tangent to the circle. Okay, there's a tangent to the circle at T. Then they also tell us that this angle STK is 36 degrees and OKL is 18 degrees. Okay, so with Euclid, the nice thing is first questions are usually okay. It's when you go to the end, that's where, yeah, things start to change. And that's why I keep saying, I personally feel like it would be better if you started with the difficult questions because your mind is tired and worn out already. Because you've been thinking for like 2 hours, 1 hour. You're going to be tired already. But okay, so here we have 8.1.1. Determine, given reasons, the size of angle T2. So angle T2 is, okay, how do we find angle T2? So let's look at what we have here. T2 is sitting here. And we know that this is OT is a radius. And they also told us that ST is a tangent, okay? ST is a tangent. So it means that the radius is always going to be perpendicular to the tangent at the point of contact. So these are things that you actually just sit down and think about it carefully. You're just going to have to really think about it. Then eventually you will start to see the answer. It doesn't just pop in from nowhere, actually. You're going to have to think about the fact that you're looking at T2. Start asking yourself, what is T2? Is it part of a triangle? Is it part of a line that I can actually find? That's how you actually think about it for you to be able to find that. So you look at all the things that are related to T2. Okay, so in that case, that's what we have. T2 is, we can go ahead and find it by saying angle T2 plus, okay, plus this angle over here, which is 36 degrees. I'm not going to say the name of it. I'll just say 36. That it's going to be equal to a total of 90 degrees. And our reason for that is because a tangent is always perpendicular to the radius at the point of contact. I'm just going to say the tangent is perpendicular to the radius. Okay, so we can find angle T2. It's equal to 90 degrees minus 36 degrees. And let's see what that gives us. So T2 is equal to 90 minus 36. And that gives us 54 degrees. Okay, so 54 degrees. Okay, another thing with Euclid is when you find these angles, it's very good to put them down because the previous question may help you with the next question. So that is 54 degrees, so put that down. Next question, we have to find the size of angle L. So angle L, and this is for how many marks? 2 marks. Okay, so it must be also just not really a very long one. Angle L is this over here. Again, the answer does not just magically pop in. You have to really think about it. Ask yourself, where is L? L is at the circumference. Okay, what can we do with that? So I was like, okay, if L is at the circumference, we have the angle at the circumference. Let's also think about the angle at the center if it's supported by the same chord. You see, here's KT, but look at that. Unfortunately, you see the angle at the center is not there. We don't have that. So we can't use that. Okay, what other theorems do you know that speaks about an angle at a circumference? There's also the case of that theorem where angles at the circumference supported by the same chord are equal. But unfortunately, this is the only one at the circumference supported by the chord KT. So we can't use that. What other theorems do we have? So there's also the angle between the tangent and the chord is equal to the angle at the circumference supported by the same chord. Okay, so there we go. So we can see now that this angle is actually going to be equal to this angle. So this will also be 36 degrees, okay, because of the tan chord theorem. I don't think you're allowed to say tan chord theorem anymore. I'm not really sure about that, but I do know that there was a time that they said you must write the reasons in full. So here we go. We can say angle L is equal to 36 degrees, and I'm just going to put the reason down. Angle between tangent and chord. Okay, so there we go. So put that in, and so we know what angle L is now. Moving on to the next question. The next question says we have to find the size of KOT. So let's look at where KOT is. Okay, so looking for KOT, yay, okay, it's the angle at the center. You see why when you think it through, it actually helps you find other things in the question as well. So KOT is here. It's the angle at the center supported by the chord KT. And this one is the angle at the circumference supported by the chord KT. Remember, the angle at the center is always twice the size of the angle at the circumference supported by the same chord. So if this is 36 degrees, we'll find this by saying 36 degrees times 2. Okay, so how would I just put it here? I'll just say that KOT is equal to 36 degrees multiplied by 2. And so finally, KOT, 36 times 2 is 72. So 72 degrees. And you're, of course, going to have to put your reason. The angle at the center is twice the angle at the circumference supported by the same chord. Okay, so there we go. You can use that symbol for angle. It's a general symbol for angle. You can actually use that. And you see in places that I say equal to, I just use the equal to sign. Okay, so that is KOT. C is done. Then we move to 8.1.2. So since it's part of the question, I'm just going to put that down. That is 72 degrees, just in case we need it. Okay, next question. They are asking us to prove given reasons that Km is equal to ML. Okay, Km. So K to M is not a radius, equals to M to L. Okay, so this is actually one of the theorems. The fact that this is not a radius, rather it is a chord. KL is a chord. What we can actually look at is the fact that here we have O as the center. Do you see that the center of the circle is going through this chord? Remember the theorem that says the line from the center of the circle perpendicular to the chord, that it does what? It bisects the chord. So in that theorem, you really need to focus on the fact that it says the line from the center of the circle, which happens to be perpendicular to the chord. I cannot just assume this is perpendicular to the chord. That means we need to actually find that angle. Okay, so we need to find this angle over here, the angle KMO. And you see we have enough things to find the angle because we have this 18 and 72. So we can use angles in a triangle. So KMO, we're going to find that first. KMO is equal to, if you add it all up together, basically plus 18 degrees plus 72 degrees, it should give you 180 degrees because these are the angles in a triangle. Okay, and that's going to be your reason over here. So the sum of interior angles, the interior angles in a triangle, is equal to 180 degrees. And so let's just find KMO. It's equal to 180 degrees minus the addition of these two, because I'm going to add them together and take them over. So what is 18 plus 72. That gives you 10, that gives you 80, so 90 degrees. Okay, so that is 180 minus 90, which is equal to 90 degrees. See, you must never assume things yet. So now we know KMO is 90 degrees. Instead of just assuming it's 90. Now that it's 90, we can use that theorem on it. The line from the center of the circle perpendicular to the chord, what does it do? It bisects the chord. That's what we can do. So now we can actually conclude that Km really is equal to ML. So I'm going to say that Km is equal to, therefore, Km is equal to ML. And my reason now is that, so the line from center of the circle. So the line from the center of the circle perpendicular to the chord bisects the chord. Moving on to the next question. Next question, 8.2. Okay, brand new diagram. So 8.2 says, in the diagram, we have triangle RDS is drawn, RDS. Okay, and then they say A, B, and C are points on RD, RS, and DS respectively. Okay, so all of these points. Then they also say such that AB is parallel to DS. Okay, so AB is parallel to DS. Now they're giving us these. RB is to BS is equal to 5 is to 3. So that's the ratio for that. When you see that, I advise that you already put it in. You see, because it's the ratio is not speaking about the length. It's really just speaking about how it's shared. So when we're looking at RB and BS, they're saying this line, whatever the length of it is, this part, RB, is going to take 5 parts. And this part, BS, is going to take 3 parts. So what I'm going to call it, I'm going to call this 5A. Now I'm going to call it K. I like calling it K. And then 3K. So the K really just stands for parts. So I'm already putting that down. Then they say that DC is 20 units. So DC is 20 units and CS is 12 units. Okay. The first question is to prove, given reasons, that BC is parallel to AD. And this is for 3 marks. Okay, so how do we prove that BC, this line, is parallel to AD? Okay, so if it's parallel to AD, remember, it's really just the same thing as being parallel to DR, because they are on the same line, they're collinear. So how do we prove these 2 lines are actually parallel? Looking at, if you tilt your head and you look at this as a triangle, so imagine this is the top of the triangle, SRD, that triangle, right? You're going to notice now, here you have ratios, here you actually have dimensions, the actual lengths of those sides. That's perfect, meaning we can actually find this. This is using, we have to think about the proportionality theorem. Rather, it's the converse. You see, in this case, they've given you the lengths already. They only didn't give you that this is parallel. So we have to show them that it is parallel. Look at what we can do. If we take SB over BR, so SB over BR, and we find that we know that this is going to be already 3 over 5. Okay, we already know that because we have the ratios of that. Now we're going to do the same thing to this side. Let's find SC. You see, in the same form, if you take SB, you need to take SC. So SC, and here we took BR, so we need to take CD. SC over CD, and that is equal to, so SC is 12 over CD, which is 20. And if you simplify 12 over 20, what does that give you? So 12 over 20 is equal to 3 over 5. Okay, so 3 over 5. We can just say this is finally equal to 3 over 5. Now that we know this, SC over CD is 3 over 5. Do you see that they're exactly the same? So this now concludes that SB over BR is actually equal to SC over CD. So since their ratios are equal, okay, it would mean that these 2 lines are parallel. So we can conclude, now that they are parallel, we can conclude finally that BC is now parallel to AD, and the reason why is because this is the converse of the proportionality theorem. Okay, so I'm going to put the reason, but I'm just going to give more insight to this. Now, this is what I mean by that. You see, it's not the proportionality theorem, it's the converse. The reason why is the proportionality theorem, you always need to focus on what did they give me and what did they ask me to conclude. In the proportionality theorem, you're given a triangle, for example, and let's say it's ABC, and let's make this DE. They always tell you in the proportionality theorem that these two lines are already parallel. You see, that's what you have been given, that DE is already parallel to BC. Now, what you would have to conclude is that AD over DB is equal to AE over EC. That's what you would conclude. Then your reason would be proportionality theorem. But if you see in what they gave us, they didn't give us that those two lines were parallel. They just gave us a triangle. They didn't tell us that they were parallel. And all they did was they actually gave us the dimensions and the ratios. So they gave you, like that was 3 and that was 5, and they gave you 12 and 20. You see, it's the opposite. It's backwards. Instead, they gave you here the conclusion. Okay? They gave you that conclusion. And so you're going to conclude this time using what you have been given here. So now your conclusion would be that DE is actually parallel to BC. They work the other way around. You see, here you are given that they are parallel. You had to conclude that they were in proportion like that. Here you are given that they are in proportion. You'd have to conclude that they are parallel. That's why this is the converse. This is not the actual proportionality theorem. Okay, moving on to the next question. Okay, so I'm also just going to say that they are parallel now, since we found out that they were parallel. Okay, so those two lines are parallel. Moving on to the next question. Yeah, I see I need space here. Hold on. Okay, so the next question, the last question for question 8 is, if it is further given that RD is equal to 48 units, calculate, given reasons, the value of the ratio AD is to AB. So this is what we need to find. They've only told us that RD is 48 units. Okay, let's see. So RD all the way here, that is now 48 units. And we have to find AD to AB. Okay, so we need to find AD to AB. Okay, looking at that, we have to actually find that, we have to find the length itself. But never get too worried with these ones, okay? Always just try to see there's probably a bigger hint in this. The previous question always has a lot to do with the next question. In the previous question, we showed them that these two lines were parallel. So think about it like that. And now that I look at it like that, I'm actually starting to see why they purposely said BC is parallel to AD. They wanted you to say it's parallel to AD instead, because they were trying to make you focus on this line, AD. Look at this. AD is parallel to BC, right? We already know that AB is parallel to DC. They told us that already. What kind of shape does that form? That is a parallelogram. All you have to do to prove that something is a parallelogram, well, there's actually 5 ways to prove something is a parallelogram. But one of the most common way that is usually used in Euclid is prove that 2 pairs of opposite sides are parallel, then it's a parallelogram. So we're going to use that. If it's a parallelogram, we are allowed to use every other thing we know about parallelograms. So that means that, remember, we're really just focusing on finding AD and AB. That's all we need. If this is a parallelogram, let me actually just state that down. I'm just going to say that ABCD is a parallelogram, and I'll say why it is a parallelogram. Okay, and the reason is because 2 pairs of opposite sides are parallel. Okay, so that's why it's very important to always write down what you have found, and highlighters are really important and they help you a lot with this. I don't know if you guys are allowed to use highlighters in like final exams and like June exams and stuff. Okay, so this is what we have now. We know it's a parallelogram, and look at now what we can conclude from this. We only have to find AD and AB. Because this is a parallelogram, the opposite sides would be equal, meaning this is equal to this. So AB, the length of AB is actually 20 units. So we found AB. Okay, so I'm going to conclude about that. I'm going to tell them that AB is equal to 20 units. And that's because the opposite sides in a parallelogram are equal. Two pairs of opposite sides are equal in a parallelogram. Okay, so now that we know AB, we just have to find AD. And that's definitely why they gave us RD. Okay, so you see these two lines are parallel. This, I don't know why I gave it the same symbol. Should be a different symbol. But anyways, these two lines are parallel. This is parallel to this. We can use the proportionality theorem here. So we can use the proportionality theorem to find the ratio of, instead of RA, I don't see a need to say that. Since they spoke about AD, right? They want us to find AD. So we're going to say AD over, and you're looking at this line and seeing, what can I put it over in this line? Put it over what you have. What we have is the length of RD. So I'm going to use AD over RD. That's what I'm going to use. Okay, so this is what I'm saying. I'm saying AD over RD is equal to, because the lines are parallel, I can use the proportionality theorem. I know the ratios here. So since I took AD here, I have to take here on this line BS. So it's equal to BS over, and then because I took RD, I have to take RS here over RS. Okay, so this is the proportionality theorem. Then I can say proportionality theorem. Okay, so I used a different reason, but you can also use that. So line drawn parallel to one side of a triangle. Okay, they're just saying one line is drawn parallel to one side of the triangle. That's another reason for proportionality theorem. So now I'm going to focus on this. Now you see, we're trying to find the length of AD. Okay, so now that we have this, we can now conclude that AD over RD is equal to what is BS over RS. So we're going to take those ratios. BS is 3 over RS in total. If you add that 5 and the 3, it's 8. Okay, so it is not the length of it, that's just the ratios of it. So that is 3 over 8. 3 over 8, okay, as a ratio. Now we can use this. Now that we have this, I'm going to try and find the lengths of this. So I don't know the length of AD. So I'm saying AD over, but I know the length of RD. The length of RD is this entire length of 48 units. So over 48 is going to be equal to the 3 over 8. And now in order to solve for AD, all you're going to do is get rid of this 48 to solve for that. So you multiply both sides by 48 and 48. And so you can say that AD is equal to, what is 3 over 8 multiplied by 48. So if we say 3 over 8 multiplied by 48, we get 18. So we know now that this is equal to 18 units. Okay, so we have AD, we have AB, and now we can actually just find the ratio of AD is to AB. AD is to AB, you can first put it as a fraction so that it can simplify as a ratio. So AD over AB, right? So let's find that. AD over AB is going to be equal to 18 over AB is 20. 18 over 20. And so this is going to simplify to what is 18 over 20, 9 over 10. So it is 9 over 10, 9 over 10. And now we can conclude finally that AD is to AB is actually equal to 9 is to 10. Okay, and that was the last question for 8.2.2. Now we move on to question 9. Okay, second last question in this paper. We are on question 9. 9.1 says, in the diagram, O is the center of the circle, A, B, C, D is a cyclic quadrilateral. We have to use the diagram in the answer book to prove the theorem which states that the opposite angles of a cyclic quadrilateral are supplementary. That is proof that angle B plus angle D just gives you 180 degrees. Okay, I have a bunch of videos on these proofs on my channel, so you can go on there and then you can see these proofs as well. I will do this one though. Okay, so here, first of all, we have to look at the cyclic quadrilateral and see how can we actually prove that this is going to be supplementary. These two angles, when we add them up together, they give you 180. Because they told you to focus on these two angles, we're going to have to think about how can we construct it in a way that this is left open and that is left open. So I'm not going to draw any line that cuts into this angle. What we're going to do is we're actually going to construct two radii. So from O to A, and then from O to C. Okay. And I'm going to just call it, let me just say, you have to actually say what you construct. So I'm going to say construct OA, line OA and OC. Okay, you have to tell them everything that you construct. Now that we've constructed that, it seems like, well, they do tell you use the diagram, okay, in the answer book. So they will already take note of all the things that you write down. So that means that I'm going to call this one angle O1 and angle O2. Even if I tell them, it's not going to make a difference because you see, even if I call this AOC, same thing as this one, AOC. Okay. So I'm just going to call it O1 and O2. Okay, now that we have that, the theorem that you use to prove this one is you use that theorem that states that the angle at the center is twice the angle at the circumference, supported by the same chord or arc. Okay, this is what we're going to do. We are going to use the fact that, you see, here's O1, it's the angle at the center. It's going to be twice the size of the angle at the circumference, supported by the same arc AC. What angle at the circumference? Now remember, it needs to be opposite. I know that this one is also supported by AC technically, but it's supported by the bigger arc, the major arc AC. Okay, so we're actually referring to this angle over here. So I'm going to say now that, but they already know because you're going to say that down. So angle O1 is equal to twice the size of angle B. Okay, so angle B. And your reason, of course, is going to be that angle at the center is twice the angle at the circumference, supported by the same arc. Okay, so that is how we find O1 first. Then we're going to do the same thing to O2. You see the angle O2? That angle at the center is going to be twice the size of the angle at the circumference as well, supported by the same arc, not the minor arc AC, but the major arc AC. The other angle at the circumference supported by that major arc AC would be angle D. Okay, so angle O2 is twice the size of angle D. So we can also say that down. Same reason, I'm just going to copy and paste. O2, angle O2 is equal to twice the size of angle D. Okay, now that we have that down, we're almost done. All we have to do is look at the fact that, you see angle O1 and angle O2. They are angles that lie around a point. And what do we know about angles around a point? That they add up to 360 degrees. So that's what we're going to say. Angle O1 plus angle O2 is equal to 360 degrees. And that's because angles around a point add up to 360 degrees. And now we already have equations for O1 and O2. Angle O1 is equal to 2 angle B. So I'm going to replace that. It's 2 angle B. Plus angle O2 is 2 angle D. So angle O2 is 2 angle D. And that is equal to 360 degrees. Then you'll notice that we have a 2 here and a 2 here. That is common. What we can do is to simplify this further, just divide both sides of the equation by 2. And so this finally concludes that angle B plus, because that divided by 2 is just angle B, and then this divided by 2, the 2's cancel, is angle D, and it's finally equal to 180 degrees. And that's how we prove that. So that one is a nice proof, nice 5 marks that you can get. It's actually one of the simplest proofs that we have in those circle theorems. Okay, moving on to the next question, 9.2, which has one question, which is like 4 marks. Okay, they say 9.2, in the diagram, we have G, E, F. What am I reading? Sorry, they say in the diagram, D, E, F, G. Okay, D, E, F, G. Okay, is a cyclic quadrilateral such that EF is parallel to DG. So EF is parallel to DG. H is another point on the circle, okay, such that DH is parallel to FG. So DH parallel to FG. A lot of parallel lines. Chord EF is drawn and you need to let angle D1 be equal to X. So there's X. This one is just a chord, so I'm not really focusing too much on it. Okay, so that is X. They want you to prove with reasons that D1 is equal to D2. Okay, angle D1 equals angle D2. You see, with these questions, you should be happy the minute you see they give you something is equal to X, because when you have an angle equal to X, it's easier to monitor the angle. If they never said let this be X and they just said angle D1 is equal to angle D2, I would really urge that you make one of it equal to X. Choose one which should be equal to X. Choose either D1 or D2. So what we're trying to do is we're starting here and we're going to try and find out how can we get from angle D1 to angle D2. We're basically trying to find that D1 eventually ends up being X. They gave a lot of parallel lines. So another thing you're going to have to look at is how these parallel lines have been drawn. These parallel lines, the first one we have this DG, right, is parallel to EF. Now, with these things, I always say that you have to actually build a strategy, a plan. You're going to have to really think about a plan. Don't just find random things, because then you end up finding things that you don't need and they won't give you marks for that because it wasn't part of the marks that you were supposed to get to find the answer. So looking at this, how do we get from here to here? Since we have parallel lines here, you can look for things like alternate angles, co-interior angles. You can look for things like corresponding angles. That's the kind of things you can look for on parallel lines. So with these parallel lines, this is how I'm going to be looking at this. I'm trying to relate X to another angle. Well, if you're looking at alternate angles, this is not helpful. If I look at it like this, it's not helpful because, first of all, this doesn't even include X. It's not even a named angle, so it's probably showing you how not important it is. So I'm not going to even look at that. What else can we look at? Okay, so you see we have co-interior angles here. So it means that this plus this, okay, adds up to 180 because that's what co-interior angles do. But I'm not going to put that down yet because I need to still see how that relates to D2. Okay, so we're trying to let D2 relate eventually to X. Okay, so with this one, this looks like a dead end. It's not really working. If you go from here and you add this, if you find this angle, not really helpful to find D2 because you see only these two lines here are parallel. These two lines are not parallel, so I cannot look for co-interior angles like that either ways. But let's also remember that this shape that we have here, DEFG, it's a cyclic quad because you see its endpoints are on the circumference of the circle. So since it is a cyclic quad, we know that, like in the previous question, you see that's the funny thing about this. In this, the opposite angles of a cyclic quad are supplementary. So they add up to 180 degrees. Now the reason I want to actually pick this one is because look at this. If we take this D1 plus angle F, right, and we know it gives you 180 degrees, we're going to be able to find a value for this, okay? It will be in terms of X, but it will be something that we have there. Then from here, we can go to this one here. Look at this. Here, these two lines are parallel. These would be co-interior angles. And then from here, we can get to D2 because you see that we have a parallel line here and a parallel line here. And here we have a Z. So this angle is actually equal to this angle. Okay, so that is the routes that we can take. So we can start from D1. You see, you're going to have to try and create some sort of pathway from this to reach to D2. Let's start from D1. We're using the opposite angles of a cyclic quad. So angle D1 plus F is equal to 180 degrees. Okay, so it's opposite angles in, okay, a cyclic quadrilateral. That they are supplementary, okay, or they add up to 180 degrees. Angle D1, they told us, is X. So Angle F, we don't really know what that is. That's just little f. We'll make that the subject, is equal to 180 degrees. So this means that angle F is equal to 180 degrees minus x. Now we have something for that. So I've used that. I can erase that. I'm going to say this is 180 degrees minus x. Okay, so now that we have that, we can say that this angle, angle F, plus angle G, that they will add up to 180 degrees because they are co-interior angles. You see? Here's your parallel lines. So angle F plus angle G equals 180 degrees. Okay, so that's because co-interior angles on parallel lines are supplementary. You can use that symbol for parallel. Okay, angle F, we know that is 180 degrees minus x, and then plus angle G is equal to 180 degrees. If we simplify this, we're saying that angle G is equal to, we still have 180 degrees here. I will take this one over minus 180 degrees, and I'm taking the negative x over plus x, and so angle G is equal to x. Okay, so this is what G is. G is x. Erase that. I don't really need that anymore. And then lastly, we can also see now that G is going to be this over here. Here's alternate angles. So angle D2 is equal to angle G because of alternate angles. So we can say that. Again, this is because alternate angles on parallel lines are equal. And so I can go ahead and say that angle D2 is actually equal to x. Okay, angle D2 is equal to x because that's what G is. And now, since angle D1 is equal to x, it means that these two are equal. So you can put that if you want, just like a conversation. Since angle D1 is equal to x, it means that angle D1 is therefore equal to angle D2. So there we go. And that is how that is solved. So you see we have 3 steps here, 1, 2, 3, and a conclusion. So that's probably where the 4 marks is going to. Okay, that is the end of question 9, and we move on to question 10. Okay, we're finally on the last question, question 10. So question 10 says, in the diagram, TR is a diameter of the circle, and then we have so TR, that's a diameter, very important. And then we have PRKT is a cyclic quadrilateral. Okay, we have a cyclic quad, so we can use all the properties of a cyclic quad on that. Then chords TP and KR are produced to intersect at S. They're chords, so they're just lines, okay? And then we have chord PK is drawn such that PK is equal to TK, okay? That is important to note because they're telling you 2 things that are equal. So PK equals TK. PK is equal to TK. And they already marked it for you. So first question, 10.1. Prove given reasons that 10.1.1 SR is a diameter of a circle passing through the points S, P, and R. They want you to show that SR is a diameter of a circle passing through these points. As you can see, S, P, and R are here. So you kind of have to draw the circle by yourself, right? So imagine there was a circle here. Just try to draw it around and use... Okay, let me just fix that. Okay, so this is the circle, and they're telling us that we need to prove that SR is a diameter of the circle. So how do we show them that this is a diameter? You see, with these types of questions, you're going to have to now think, how do we prove something is a diameter? What theorems ever spoke about a diameter? There's one specific theorem that tells you about the diameter. It says that if you have a circle and you have a diameter, and then there's an angle supported by this diameter, that angle is going to be 90 degrees. You would also know this theorem as angle in a semicircle. Let's look at that. If they're saying SR is a diameter, so let's think about the angle supported by SR. S and R right here. The angle supported by that is like this. Okay, it's going to be this angle, P3. If we can show them that this angle is actually 90 degrees, then it would mean that SR is a diameter. So we are required to prove that angle P3 is going to be equal to 90 degrees. Okay, if we can show that's 90 degrees. So now we know we just need to find that angle. How do we find P3? Okay, so let's just look at a whole lot of things that relates to P3. So P3, this is a triangle, and we can look at the fact that here, look at this, we have a cyclic chord. Okay, so you have a cyclic chord over here, and P3, you see that this line TPS is a straight line. So this would be the exterior angle of the cyclic chord. The exterior angle in a cyclic chord is always equal to the opposite interior angle. So this entire angle. Okay, so our goal is to find P3, to actually show it's 90 degrees. If it's equal to this, then this one is also equal to 90 degrees. So let's find out, how can this be 90 degrees? Okay, let's look at that. How can this angle over here be 90 degrees? Well, they told us about a diameter of the bigger circle. TR is the diameter of the bigger circle. Since this is the diameter of the bigger circle, then this angle is 90 degrees. Okay, so you see, it's you start from somewhere, you start moving. Okay, don't try to find random things. Try to focus on that goal. So I'm actually going to start by saying angle K, okay? Or you can say K1 plus K2. I'm just going to call it K because it's the full angle. Angle K is equal to 90 degrees because of angle in a semicircle. Okay, angle in a semicircle is equal to 90 degrees. That's a shorthand way. You could have said angle supported by a diameter is equal to 90 degrees, but that is longer. Okay, so this is what we have now. I know this is now 90 degrees. Okay, and we've already figured out that this PRKT is a cyclic chord, and this is the exterior angle of that cyclic chord. Okay, that's the line, and it's equal to the opposite interior angle. So that's what we're doing now. P3 is actually equal to K, angle K, okay, which is 90 degrees. So P3 equals angle K. Angle P3 is equal to angle K. And angle K, the reason why is because of the exterior angle of a cyclic quadrilateral being equal to the opposite interior angle. Okay, and so now I can conclude that angle P3 is actually equal to 90 degrees. And there we go. Remember, I said that in order for you to show that SR is actually a diameter, you have to show them that that is actually 90 degrees. Okay, so because of that, I can conclude and say that SR is a diameter passing through, and of course you're going to say the same thing, passing through the points S, P, and R. Okay, and the reason, technically, this is it's more of the converse of this, because usually in this theorem, you are given that this is a diameter, and then you conclude that that angle is 90 degrees. But in this one, we found that this angle was 90 degrees, and we are concluding that this is a diameter. So I'm just going to try and switch the words a bit for you to really just say it like it is a converse. Okay, so I just decided to use the same reason. The angle supported by a diameter in a circle is 90 degrees. Okay, so that's how we prove that SR is actually a diameter. Moving on to the next question. How many more questions do we have? 3. Okay. So moving on to the next question, we have 10.1.2. We have to prove that angle S is equal to angle P2. Okay. Angle S being equal to angle P2. So just keep everything that we found. We found this was 90 degrees. We found that that is 90 degrees. So how do we show them that angle S is equal to P2? So S is over here. Okay, S must be equal to P2. P2. Okay, you can start from either one of it and then start working your way to it. So starting from, you can choose anyone to start from. I feel like P2 can move around more freely. So I'm going to start from P2 because you see I have lines crossing like that. So we can use that theorem that looks like a butterfly. The theorem that states that the angles at the circumference supported by the same chord are equal. So it means that P2 should be equal to this angle over here, T2. See, because they're both being supported by KR. Okay, so I've just moved from P2 to T2. I need to move from T2 eventually to get to S. Okay, so with T2, this might not actually work. So I'm seeing a dead end. I can't really move this T2 anywhere else. Okay, so let's use something that includes angle P2. Okay, so we're just trying to look at angle P2. If we look at angle P2 and angle P1, right, those angles together, they're going to give you, because this is a straight line, if this one is 90 degrees, this is also 90 degrees, okay? When we add them together, we get 90 degrees. Okay, so in other words, they're also equal to this angle over here. They sum up to 180 degrees together. So they're both 90 and 90. Okay, so I'm going to use angle P1 plus angle P2 is going to give me this entire angle K, right? But I know it's equal to 90 degrees. Weirdly enough, we have two lines that are equal here. Okay, but we always have to see, how does this relate to S? If these two, okay, P1 plus P2 is equal to 90 degrees. Okay, so that P1 plus P2, of course, their angles equal to 90 degrees. And I'm using this because it has P2, which is what we want to find. But because we have two lines that are equal here, this line is equal to this line, right? It would mean that their base angles are equal. So we have an isosceles triangle. This angle is equal to this angle. Okay, if you have a triangle and this is equal to this, then these two angles below it would be equal. Okay, so this really just means that angle P1 is going to be equal to the angle T. Now, if we relate this to the angle T, there's a 90 degrees in this, okay? So in place of P1, we'll put T instead. So we have T plus P2 is equal to 90 degrees. We're trying to find that P2 is actually equal to S. How does this relate to S? Well, if we look at this triangle, this entire triangle, you see that this entire triangle has a 90-degree angle and it has angle T. So we can definitely relate that. Okay, so I'm going to start like this. I will first start by saying that angle P1 plus angle P2 is equal to 90. So angle P1 plus angle P2 is equal to 90 degrees. Okay, and we don't really need a reason for that. That's already proven. You can't say angles on a straight line because technically, yeah, that's how, since this is 90, this entire thing is 90. So yeah, technically it is angles on a straight line. Okay, because we had another 90 degrees. Okay, so I'm just concluding basically that they are 90. Then in place of, now because we know that PK is equal to TK, so I'm going to say, but we know that PK is equal to TK, which is already given. And so this concludes that these two angles are equal, the base angles, like I said here. So it means that this entire angle of T is equal to this angle of P1, because this is an isosceles triangle that we have over here. Okay, so angle T is equal to angle P1. Angle T is equal to angle P1. And our reason for that is not really isosceles triangle, but it's because the angles opposite equal sides are equal. Okay, angles opposite equal sides are equal. Okay, then now this equation, I'm going to conclude, in place of P1, I'm going to put angle T. So angle T plus angle P2 is equal to 90 degrees. And I'm going to now make angle P2 the subject. Angle P2 is equal to 90 degrees minus angle T. This is what we have here for P2. Okay, and we just have to prove that P2 is actually equal to angle S. Now we can focus on S. Now S is from this big triangle, which has a 90-degree angle for K, and it has T, which is really all we need, a 90 degrees and T. So I'm saying that angle S plus angle T plus the 90 degrees should give you 180 degrees because of the interior angles of a triangle. Okay, so angle S plus angle T plus 90 is 180 degrees, sum of interior angles in a triangle. And then I'm going to make angle S the subject, okay, just to show that it actually is that. So take the 90 over and take the T, angle T over. Angle S is equal to 180 degrees minus 90, minus angle T. So angle S is equal to 180 minus 90 is 90 degrees minus angle T. Okay, now you can see 90 minus angle T, 90 minus angle T, both for angle P2 and angle S. So that concludes that angle P2 really is equal to angle S. Okay, so you see, it's a thing that you really have to think deeply and don't find random things. Always see how things relate. I was actually even showing you how I thought about it. At first, I thought, okay, maybe we should use the angles at the circumference supported by the same chord, but you saw that didn't even work out. Okay, and you see where you can't really use something, where you see it can't even go further than that, then you leave it and try something else. Okay, moving on to the next question. I think it's still related to this. Yes, we have to show, second last question, we have to prove that, I guess, because it's proving all through here. Yeah, prove given reasons that triangle SPK is similar to triangle PRK. Okay, let's highlight those triangles. Before highlighting those triangles, let's put the things that are equal. P2 is equal to S. So I'm going to put that down. P2, let me just clean this up. Okay, so I'm saying that angle P2 is equal to angle S. So let's say the triangles that they are referring to, they said SPK and PRK. So let's highlight these. So SPK, that's that triangle over there. And then PRK. So PRK, let's use another color. I'll use that. So PRK is PRK, P all the way to R, small triangle, and K. Okay, so there we go. Those two triangles, we have to prove that they are similar. Okay, so to prove they're similar, we have two ways, the two methods to prove two triangles are similar. You can either prove that all their angles are actually equal, or you can prove that all their sides are in proportion. In this situation, they have not given you any lengths, nothing like that. So we have to go with the angles. We have to show that all the angles in these two triangles are equal. You see, the way they name the triangle is very important. The minute they name the triangle for you, they're already doing half the job for you. Triangle SPK, right? And triangle PRK. From S to P to K. It means they're speaking about this angle S, right? It's probably equal to the angle P in that blue triangle. So PRK, so speaking about P2. Okay, and you can see those are already equal. We can already start stating that. And then we have, after S, we have P. So S, P, then K, right? So this P is referring to P3 all the way to P2, that huge angle, right? And they're saying that, well, we're tying it to this. So when we have PRK here, I'm going to look at it as PRK. So the second angle here is this entire thing. So it's probably that these two are also equal. But let's just see, maybe the third one is equal. They see SPK, that's at K2. And PRK is also ending at K2. That is a common angle that you have. So this one is going to be very easy to prove that they are similar. Always start by introducing the triangles. You're saying in triangle SPK and triangle PRK, let's say the things that are equal. First of all, we see that we already have that angle S is equal to angle P2 in both triangles because this has been proven already. So we can say that angle S is equal to angle P2, and I'm just going to say proven. That's the reason. Then the second angle that is equal was this common angle of angle K2, okay? SPK, PRK, ending at the same thing. Angle K2 is equal to angle K2. So we can say that angle K2 equals to angle K2, and the reason is because it's a shared angle. You can say common angle or shared angle is still fine. Okay, so this is a proven angle, just to show that it is angles we're working with. And then the last side, or so last angle in these two triangles is this angle. Remember, SP all the way to K. So this entire angle from P3 to P2 and PRK, this entire angle. You see, you already have two angles in those two triangles being equal. By default, these last two angles would also be equal. Okay, so the reason for that, we can just say third angle in a triangle. It's kind of like you have two triangles. This is 30, this is 90, that is 30, this is 90. Then of course, this one over here is definitely going to be equal to this one over here. Okay, so that's how that works. Okay, so I'm going to conclude those two are equal, but I'm not going to call it I'm not going to call it that. I'll just call it SPK is equal to PRK. And that is because this is the third angle in a triangle. If you like, you can say sum of interior angles in a triangle is still fine. So here we have three angles equal. Therefore, it means that triangle SPK is similar to triangle PRK. Okay, so that is 3 marks. Moving on, and we are finally at the last question. Question 10.2, and this is for 5 marks. They say, if it is further given that SR is equal to RK, we need to prove that ST is equal to the square root of 6RK. Okay. Now, this could mean a whole lot of different things. They could be using anything. They could be using the proportions of the sides of the two triangles, and I think that is definitely what you need to go with, because you must always look at what the previous question was. They asked you to prove two triangles were similar. They're probably referring to the sides of the two triangles here. So I'm going to use this, okay? If it's further given, okay, so we have to actually put that down as well. They did tell us that it was further given that these two are equal. So SR equals to RK. Let's go mark that. SR, this is equal to RK. So this is equal to RK. Okay. So that's what we have. Okay, so long I'm just going to get rid of these lines. Well, I'll leave the equal angles, but the lines of the triangle. So this is what we have. And they want us to, okay, and they want us to prove that ST is equal to this. So basically, you see, they're saying ST is equal to square root of 6RK. Find ST, but it needs to be in terms of RK. Okay. Using the fact that, let's look at this and see what we can use. We want to find ST. Okay. ST is this entire length. So this entire length, and it needs to be in terms of RK. Well, that's not bad because we know RK and SR are equal. So why don't we just call this SR RK instead? Okay, call that RK, and this is already RK. That's one step. So I'm going to already say, well, I don't actually have to say that. Since we already know, I'm just going to state it. It's not one of the solutions. I'm just going to state it. Since SR is equal to RK, right? So meaning when I see SR, I'm not going to call it SR, I'll call it RK. What else can we see here? Okay, let me use different lines for this because there are these lines already here. Okay, apart from that, we have to find ST. Looking at that already, you can see that this is a right angle triangle. We had a surd. They said ST was equal to the square root of 6RK. The way we could have gotten a surd is if you used Pythagoras, because you know you're going to have something squared, and at the end you're going to have to square root both sides. That's probably where the surd came from. So Pythagoras was probably used. But you see, since we have to find ST, that will be our subject, and we've already put these two in terms of RK, which is good. That's one side of the triangle. All we kind of have to do now is actually find TK. So can we find TK with what they have given us? Okay, so how do we find TK? Well, remember also previously they asked us to prove that these two triangles were similar. Let's try and use those proportions, but we will include TK in it. We can include TK. But the thing is, TK is not really here. Okay, so let's use these proportions and let's see what we can use from it. Okay, something we should also remember that PK is equal to TK. And we know that PK is part of this triangle that we were proving basically is similar. So let's use the proportions of that triangle, but we're going to include PK, right? And then because our solution, the thing that it asks us to find, includes RK, we will use this entire side, okay, SK. Okay, so this is what I'm saying. You see, we've proven that these two triangles are similar. So since these two triangles are similar, I'm trying to use things that actually have what we have here. We have ST, we have RK. That's the kind of things they kept mentioning in these triangles, okay? Now, ST, we'll find that on our own. That is a separate side. Here, let's focus on the things that have RK. In these two triangles that we had to prove are similar to each other, it was this bigger triangle and this little triangle over here. Look at the sides that we can use. So in the bigger triangle, SPK, we can use this side PK. It's going to be one of the sides we include. Now, if you're using PK, you're going to have to use it with RK. See, because it's the second and the third point. Second and third point in the other triangle that it's similar to. So I'm using PK over RK. Okay, and see, RK is already included. Is equal to, what other two sides can we use? So in this big triangle over here, I included this. Why am I including this? Because this line is equal to TK. And to find this hypotenuse, we need TK. You see, so I'm just going to eventually replace PK with TK. That's why I'm putting TK here. Okay, PK over RK is equal to, and then in this triangle again, what other side would be best to use? You can't use PS. They never said anything about PS. You can, however, use SK because that one is named in terms of RK. We're trying to stick to what the solution had. It had RKs in it. It had ST, but ST is the hypotenuse, of course. Okay, so I'm going to use those things. So I'm going to use SK. So since I'm using SK, here I have to use this over as over PK. So that's how you use the proportions once you have proven that the triangles are similar. Okay, so now that we have this, in place of PK, we can replace that instead with TK. Okay, so PK can now become TK because we know that those two lines are equal. Okay, those two sides are equal. So before I forget, let me actually put this down. And the reason that I'm using this is because the triangles are similar. You can just say your reason is similar triangles. Okay, so that is down. And then let's see what we're going to replace, basically PK. Okay, because it's equal to TK. So in place of PK, we're saying TK over RK is equal to SK over TK. Okay, now everything is actually starting to relate. TK is fine. We want TK to be in the equation because you see, using Pythagoras, we had the TK over here, okay, as part of this big triangle. We have TK. So the only thing that looks like it doesn't actually fit in here is SK. RK is fine. RK was part of the solution, okay, in what we have to find. It's SK now that looks weird. So what can we change SK into? Well, if we look in the diagram, you see that from S to K, this is made up of SR and RK. And we already know SR is actually equal to RK. So that SK, the entire thing, is just double of this. It's 2RK. Okay, it's that plus that. So since SK is equal to 2RK, I'm going to replace it with 2RK. So this, now I'm saying, therefore, TK over RK is equal to 2RK over TK. So now we are at this point, and to simplify this further, the only thing we can do is actually just cross multiply. So let's cross multiply these two. TK times TK is TK squared, and this is equal to RK times 2RK, which is 2RK squared. Okay, that is fine. That actually looks good because now we have this TK squared. Now using the theorem of Pythagoras. So let me erase all of this. Using the theorem of Pythagoras, this is what we can do. So we can actually find now ST. We can say ST squared is going to be equal to, since it's the hypotenuse, ST squared is going to be equal to TK squared, right, plus SK squared. And we know what SK is, okay? plus sk squared. So let's use this. Okay, and that's because of the theorem of Pythagoras. And so now we can say we're just trying to find st. So st squared is equal to tk squared. We have that. That is 2rk squared. And sk squared, well, we know what sk is. Okay, and I changed it from here, weirdly enough. I didn't actually need to change it from here. sk, right, is equal to 2rk. We saw that already from here. This entire length is equal to rk plus rk. So we'll say plus 2rk, and then we need to take this and make it all squared, because that is just sk on its own. We still have to square it. Okay, so this is now st squared is equal to 2rk squared plus the 2 gets squared, becomes a 4, rk gets squared, becoming rk squared. So st squared is equal to 2rk squared plus 4rk squared is 6rk squared. Then to solve finally for st, because that's what they want us to solve for, so we would square root both sides. We don't have to think about positive or negative. These are lengths. Length is never negative. So st is equal to the square roots. You see, 6 is not a perfect square. If you square root 6 on your calculator, it's just going to say square root 6. But if you square root rk squared, it's like square root in x squared. It will give you x. Same way, this will just give you rk. And that's how we find out that st is equal to square root of 6 rk. Okay, so that's the end of this video. I hope you enjoyed it, and I will see you guys in the next videos.